Hello and welcome to the Object-Oriented Programming course in Python. I'm Majid and I've been a software developer for more than 15 years. And during this time, I have worked with various programming languages including C++, Java, PHP, and of course Python. In this course, I will be your host and I hope to be able to share my experience and knowledge about object-oriented programming in Python with you. Object-oriented programming, or OOP for short, is a computer programming model that, as you can guess from its name, it breaks the program on the basis of the objects in it. An object can be defined as a set of attributes and methods. If you find this definition hard to grasp, don't worry. Later, we will see lots of examples that definitely help you to understand the concept. Object-oriented programming has lots of advantages. Because OOP breaks your program into individual objects, it is well suited for programs that are large, complex, or actively updated or maintained. The organization of an object-oriented program makes this approach beneficial for collaborative development, where projects are divided into groups. Because each developer can focus on an object and finally their codes are put together to build a larger program. The next benefit of OOP is reusability. You can create once and you can use your code multiple times in different projects. Given the many benefits of object-oriented programming, many of job postings require you to be an expert in using this approach. So if you want to be an expert programmer and get a good job, it's essential to learn object-oriented programming. And if you're looking for a comprehensive and highly practical course that takes you from zero to hero in object-oriented programming, this course is definitely what you're looking for. In this course, we will begin with the basic concepts in object-oriented programming paradigm such as class, objects, attributes, and methods. We will then move on to advanced topics in object-oriented programming including inheritance and encapsulation. And finally, I will show you how to make your classes more user-friendly and powerful using something called magic methods. In this course, we will be starting from very beginning, and there really isn't too much I expect you to know about OOP before starting this course. However, you do need to have some of experience with coding in Python. If you don't know anything about Python programming language, this course is not for you. You will definitely need to take a course on Python first, and then come back and take this course. During this course, we will implement several different examples of classes, and I hope these examples help you to better analyze any given problem statement and develop a mental model of objects necessary to create software. So, by the end of this course, you will be able to develop understanding of writing object-oriented programs that combine functions and data. I don't want to waste the time because I'm really excited to start the course, and I'm sure you are too. So let's get started.
Welcome to the course. Please watch this video as we have some important information that you'll need to get the most out of this class. This course is video-based but does include downloadable exercise and instructor files. The exercise files relate to specific exercise videos. Don't worry though, your instructor will tell you which files to open for each exercise. The instructor files are the files we used when creating the video sessions. You can follow along if you wish, but that's entirely optional. You can download the files from the next module, and here's how. Once you've downloaded the files, you'll need to unzip them. If you've not unzipped files before, here's how. All of our videos are high definition. Depending on your internet speed, Udemy may default to a lower playback level. We recommend viewing in high definition. Here's how you can change that. If you want to speed up or slow down your video playback, you can do that too. And here's how. Udemy may ask you to review this course after you've only completed a few modules. We know that can be annoying, as it's like being asked to review a 2-hour movie after 5 minutes. It's up to you when you want to leave a review. We hope you enjoy the course.
Hi. In the first chapter of this course, I will talk about basic concepts in object-oriented programming, which is usually called OOP. Object-oriented programming is a programming paradigm that is based on the concept of objects. In fact, objects are the basic units of object-oriented programming. So you might ask what the object is. Objects are everything in the real world that you can imagine, such as a car, house, students, or anything like this. If it's still confusing, let me show you some examples. Suppose you are going to create a university management system. In such a system, you can see lots of concepts, including students, professors, courses, classrooms, employees, textbooks, and exams. Each of these can be considered as an object, and each object has two parts, attributes and behavior. In this system, think about student as an object. What are the attributes for one student? Each student has name, student number or ID, age, the courses that he or she has passed, and many other attributes. How about behavior? A student can at least take a course or withdraw from the course. So student has two behavior or two methods. As another example, suppose you are thinking of designing a game like the River Raid Atari game. On the screen you can see lots of things. The airplane, the enemies such as helicopters or a ship, and the fuel station. All of these can be considered as objects that have attributes and methods. Here, for example, if you think of airplane, you find that it has some attributes such as location, shape, fuel, or a score. Also, the airplane has some behavior. At least it can move right, it can move left, it can shoot the enemies, and it can refuel. As a more abstract example, suppose that you want to develop an application like Paint in Windows. In this application, shapes including circles, rectangles, polygons, and triangles can be considered as an object, and each of them has attributes and behaviors. For example, consider a circle as an object in your mind. What attributes and methods you can think of for a circle? A circle has a radius, color, location on canvas, and thickness. And also it can have some methods or behavior. For example, you can move a circle to right or left or up or down. You can change its color. You can delete it from the canvas, and so on. And these are behaviors or methods for a circle. I hope these examples have made it clear to you about the basic concepts in object-oriented programming and give you an idea about how to think of everything as object. You should be able to find attributes and behavior for any objects. But if you still feel difficulty in understanding object-oriented programming, don't worry. Object-oriented programming is a broad concept and it's not quite possible to grasp all at once. In fact, mastering OOP can take several months. It totally depends upon your practice. In this chapter, we will take an in-depth look at the concept of object-oriented programming in Python, and I hope it will be helpful for you. In the next video, we will start coding and implementing the first object in Python. In the previous video, I talked about the concept of object in OOP paradigm, and I showed you that you can think of anything as an object. So now that you know a little more about what an object is, without wasting more time, let's define our first object in Python. Suppose that you want to develop a bank account system. In this system, there are many objects such as customers, bank accounts, credit cards, checks, and mortgages. Here, let's focus on bank account as an object. What attribute a bank account has? At least you can think of its number, holder's name, and balance. So the bank account has three attributes. It has more attributes in the real-world application, but here it's just an example. So let's jump into code and see how to create a bank account object in Python. Before creating the bank account object, first I want to show you that you are already familiar with the concept of objects, methods, and attributes in Python, and you have used them before. At this point, you may think OOP is entirely a new concept to you and you don't know anything about it, but actually it's not true. First, let me create a new Python file named main.py. I'm using VS Code, and in VS Code, to create a new file, you just need to click on Explorer in the left sidebar and then click on New File icon to create a new file. And here, let's create a list with some data. When you create a list like this, you in fact create an object of type list. A list has some data and some methods. You can access data using indexing operator, and you can call its methods using dot notation. For example, to call append method, I can say l.append and then I pass a new value as argument. As you see, you know how to create a list object and how to work with its methods. Similar to lists, dictionaries, strings, and sets are objects that you can work with them. But the question is how we can create our own data type or objects. So let's get back to the bank account problem. In Python, when you want to create a user-defined object like bank account in our example, we have to define a template for it. In programming terminology, this template is called a class. So when you think of an object, you first need to create a class for that object. It's a good habit to define your classes in separate files. So first, I create a new Python file named bankaccount.py, and then I define the bank account class in this file. So again, I click on new file icon, and here I create bankaccount.py. In Python, you can create a class using the class keyword. Here, I want to create a class for bank account objects. So I type class, and then I specify a name for my class, which is bank account. In Python, the name of classes starts with capital letter by convention, and I strongly recommend you to follow this convention. After the name of class, just like defining a function, you need a colon, and in the following line, we will write the body of the class. Again, just like function, every class in Python should have a body, and if you don't define a body for the class, it will cause a syntax error. So here, let me type pass, which for Python means the class doesn't do anything. This is the simplest definition for a class in Python. Just after this simple one-line definition, you can use this class to create an object. To do this, first let's go back to the main.py, and I remove these two lines. And to be able to use the bank account class, which is defined in bankaccount.py, I have to import it. So here I type from bank account with lower b, which is the name of the file, import bank account with capital B, which is the name of the class. And now I can create a new object from this class. To do so, I say acc1 equals bank account. And that's it. We created our first user-defined object in Python. Now let's print the type for acc1 and run our code. To run the code, go to the Run menu and click on Run without debugging. Here, as you see in the terminal, it says that acc1 is a bank account. Although you created your first object, it's a useless object. In fact, it doesn't do anything because we didn't write the body for our class. So let's get back to the class definition and complete our template for bank account object. When you create an object from a class, a special function named __init__ is called under the hood. This function is usually called constructor because it is responsible for constructing a new object. We should define this function and specify what we want to happen when an object is created. Here, inside the class body, instead of pass, I have to define this function. So I type def__init__, and inside this function, I print a message. A new bank account was created. Before I continue, let me explain a bit more about this function. When we define a function inside a class, like this function, it is called a method instead of a function. So method is nothing but a function that is defined inside a class. Second, __init__ is a special method. Its name starts and ends with double underscore. We usually name this method dunder init dunder, and dunder is short for double underscore. We have many special methods whose name starts and ends with dunder. We can talk about them in the last chapter of this course. The last point in defining a method is that the method of the class usually takes a parameter called self that represents the instance of the class. It means that self point to the object and we can access the attributes and methods through this parameter. If it's not clear or hard to understand, don't worry. For now, just accept it that the first parameter for methods is self. So here I add self as the first parameter. Okay, now let's go back to the main.py file and run this code. As you can see in the terminal, you can see the message a new bank account was created. This is printed because by creating an object, the init method of the class runs. As we discussed earlier, a bank account has 3 attributes. So let's complete the definition for bank account. Here inside the init method, I want to say the bank account has an attribute called number. As I told you, inside the class, we can access the bank account object by using self. So here I say self.number equals 123. Similarly, I define holder and balance for this object. Now let's go back to the main.py. Here, after creating ACC1 from bank account class, I can access its attribute. Here I say print ACC1, and to access number, I use dot notation. Similarly, I can print ACC1.holder and ACC1.balance. Now let's see the output. As you can see, we can access all attributes for our object. Now let's define another bank account. To do so, I say ACC2 equals bank account. And now let's copy this code to print attribute for this new bank account. And instead of ACC1, I have to say ACC2. Now let's see the result. As you see, both accounts have the exact attributes. It's because in the init method inside the class, the holder attribute is always set to Alex. But in practice, this is not what we want. We want to create different bank account. When I create a bank account here, I would like to say holder equals name, the number is 123, and the balance is $10. Similarly, I would like to set the attribute for the second bank account. By passing these arguments to the class, in fact, I'm passing some argument to the class constructor. So let's go back to the bank account.py, and here for the init method, I have to set 3 parameters: holder, number, and balance. And inside the method, instead of setting attributes to fixed values, I set self.number to the number, which comes as input argument. And let me do the same thing for other parameters. Now let's go back to the main.py and run this code. As you see, this time we have 2 different bank accounts objects, and each of them has its own attributes. The number for the first bank account is 123, and the number for the second one is 567. The holder of the first bank account is Alex, and the holder for the second bank account is Bob. The balance for the first bank account is $10, and the balance for the second bank account is $100. In this video, you learned how to create simple class, how to define constructor method, how to define objects from the class, and finally, how to access the object's attribute inside and outside of the class. Now, you can do the exercise 1 for this chapter. In the next video, you will see how to add methods to your class. As we discussed earlier, objects are defined by their attributes and methods. In the first video of chapter 1, you learned how to create your own class and add some attributes to the class. Consider the bank account object we created in the last video. We saw that the bank account has 3 attributes: account number, holder's name, and balance. Now let's see what methods a bank account object has. Just think about what we can do with our bank account. We can deposit money into the bank account, and we can withdraw money from a bank account. So these are 2 behaviors of a bank account object. In this video, we will see how to add methods to our class. Now let's go to the code and see what we can do in practice. This is the bank account class we created in the last session. This class has 3 attributes, but it just has 1 method. The only method in this class is $init method, which is invoked implicitly when we create a new bank account object from this class. Now, let's see how we can add deposit and withdraw methods to this class. As we talked before, methods are functions that are defined inside the class. So, inside the class, I define 2 functions. The first one is named deposit, and the second one is named withdraw. And as I told you in the previous video, we have to pass self as the first parameter to the methods. So I add self to the both methods. When defining methods, I usually recommend my students to use a top-down approach. In the top-down approach, you imagine that the class definition is completed. Now, how would you like to use the object? How would you like to call its methods? Here, let's go to the main.py, and here, after creating ACC1 from the bank account, how would you like to deposit money to ACC1? I would prefer to say ACC1.deposit $20. And it means I want to add $20 to ACC1. It means the deposit method needs an input argument. So now I go to deposit method in bankaccount.py here, and I add another parameter called amount. And inside the method, I have to update the balance with the amount of money. So I say self.balance plus equal amount. Note that inside the method, I can access balance through the self parameter. In other words, you cannot say balance plus equal amount, because balance is not defined inside the method. So let me remove this line. Okay, now let's complete the withdraw method. Again, in top-down approach, we imagine that the class is ready. Let's go to the main.py. How would you like to call the withdraw method? I would prefer to say acc1.withdraw $10. It means that withdraw method needs another parameter. So let's go to the bankaccount.py. Here in withdraw method, I add another parameter called amount. The implementation of this method is a bit more complicated. We cannot withdraw any amount of money from the bank account. It should be equal or lower than the balance. So inside the method, first I say if amount is equal or lower than self.balance, then self.balance decreased by the amount. Otherwise, a message will be printed, not enough money. Before we run our code, let me slightly modify the init method. Here, I want to define a default value for the balance, which is 0, because when we create a new bank account, it makes sense that it has no money in it, or the balance is 0. Now let's go to the main.py and make some modification to this file. First of all, I delete the balance for the account 1. I can delete it because the balance has a default value inside the init method. Also, let me comment ACC2 and just focus on ACC1. And before and after each of these transactions, I would like to print the balance to make sure that these transactions are done correctly. So let me copy from here and paste it here, also here and here. And oh, I made a mistake in typing withdraw, and let me correct it. Also, let me withdraw some more money. Here I say acc1.withdraw $15, and then I print the balance for acc1. And now we can run our code. Okay, as you see, after creating the bank account object, the balance is 0. And then we deposit $20, so the balance is $20. And after that, we withdraw $10 from the account, so the balance would be $10. And in the next step, when we want to withdraw $15 from the account, because it's more than the balance, this transaction cannot be done. So the message "not enough money" is printed on the screen, and the balance will remain $10. Well done. In this video, you learned how to add methods to your class. Now please go to the assignment section and do the assignment for this video. So far, you have learned the concept of class, object, methods, and attributes. In the last two videos, we defined a class for bank account. And in this video, I'm going to introduce a new special method called $$, which is responsible for printing objects. So stay tuned and let's jump into code to learn more about this method. This is the code that we completed in the previous lesson. Let me directly jump into the problem with this code, and then I will show you how to solve this problem. In the main.py file, first let me comment all the lines except the line for creating ACC1. In VS Code, there is a shortcut for commenting multiple lines. You need to select the lines and then hit Ctrl/. Now, like other data types like strings, lists, or dictionaries, I would like to print this bank account object. To do so, I say print acc1. Note that instead of printing attributes such as acc1.number or acc1.holder, this time I would like to print acc1 as a whole. Now let's run the code and see the output. As you see, it prints a strange message that only tells us the object is a bank account, but it doesn't give us more information about this object, such as its number, its holder, or its balance. If you remember, when we creating an object from the class, the init method was called behind the scenes. In fact, the init method is not called directly. Instead, it is invoked implicitly by Python. The story for printing an object is very similar. When you print an object, a special method called $str is called under the hood. This method returns a string description of an object. So if you want to print more informative description about the object, you have to define $str method in your class. So let's go to the bank account class description in the bankaccount.py here and define $str method. So here I type def $str and then I pass self as the first parameter like other methods, and inside this method I have to return a string object. This string is better to include the class name, which is the bank account here, and then the attributes, or at least a list of most important attributes of the object. Here, because we have just 3 attributes, I list all of them: self.number, self.holder, and self.balance. Now let's go to the main.py file and then run this code. As you see, this time, instead of a previous strange message, a very descriptive message is shown. In this video, you learned what $str method is and how you can work with it. This is the second special method that you have learned in this video, and during this course you will learn many others as well. There is assignment for this video in the assignment section, and I suggest you to do it to make sure that you have learned how to use $str method. Hello and welcome to the last video of chapter 1. In the previous lessons of this chapter, you learned the basic concepts of object-oriented programming in Python. Now you are able to define your own classes that have attributes and methods. Although objects are defined as an individual concept, they usually work together. Sometimes you need to use an object inside another object. Let me give you an example. Suppose that you want to create a shopping list application. In this application, the shopping list might be an object. But what are the attributes and methods for a shopping list? In practice, the attributes and methods you consider for an object depend entirely on the definition of the problem and the needs of the end users. In this example, suppose that a shopping list has a title and a set of products. And what about methods? At least we should be able to add a product to shopping list. Also, we want to see the products in a shopping list. But what is the product here? We can consider the product as another object. What attributes does a product have? A product has a title and quantity. And what about methods? We can change the quantity for a product, so it has just one method. As you see in this example, we have a shopping list object in which there is another object named product. This video will show you how to define objects that use other objects. So let's jump into the code. Before everything, let me create a new Python file named shoppinglist.py that is going to contain definition for product and shopping list class. To do so, I just click on the Explorer on the left sidebar menu, and then I click on new file icon, and here I type shoppinglist.py. And here in this file, we have to define our classes. When dealing with some related objects, we usually start with the smallest one. So let's start with creating a class for product. Here I say class, following by the name of the class, which is product, and colon. Inside the class, the first method I should define is $init method, which is the constructor for the class. So I say def $init and I pass self as the first parameter. Because each product object has a title and quantity, I take these two values as input argument in the init method. So I add title and quantity as parameters. Inside the init method, I set self.title to title and self.quantity to quantity. Okay, that's it. The definition of our init method is complete. Now let's define str method to be able to print the product. To do so, I say def $str and I pass self as first parameter, and inside the method I have to return a string that describes the object. This string tells us that the object is product, and it shows title and quantity for the product. So here I type product and self.title and self.quantity. As we discussed earlier, we have to be able to change the quantity for the product. So I define another method named changeQuantity, which takes self and a new quantity for the product. And inside the method, we have to assign new quantity to the self.quantity. Well done. The definition for the product class is complete. So let's go ahead and define a class for shopping list. Here I say class shopping list with capital S because it's a convention. And inside the class, first let's define the init method. The init method takes self and title as parameter and sets self.title to title. The shopping list has another attribute named items, which is a list that contains a list of shopping items. When we create a shopping list, this list is empty, so I initialize it with an empty list. Okay, the init method is done, and it's time to define str method for this class. To do so, I enter def $str$, and I pass self to it, and it should return a string. For shopping list object, I would like to print its type, its title, and the number of items in the shopping list. So I say shopping list, self.title, and the length of the items. Okay, now let's define other methods for this class. We need to define two methods. One is add, which is used for adding an item to the shopping list, and the other one is show for showing the items in the shopping list. Now let's complete each of these methods. The add method takes self and a new item that we want to add to the shopping list as parameters. So here I add a new parameter named new item. And inside the method I have to add new item to the self.items. And because self.items is a list, I can use append method to add new item to self.items. So here I say self.items.append new item. This single line is enough for the add method, but just as validation check, let's check if the new item is valid input or not. The new item should be an instance of product class, so I can use isInstance function. To do so, I say if isInstance new item and product, then append the new item to the list. Otherwise, we can print a message that shows the new item is not valid. So here I say else print new item is not a product. Also, let me print a message here that shows the adding is successful. Here I say print the new item was added to the list. The definition of add is complete. Now let's continue with the show method. The show method should only print all products in the shopping list, so it doesn't need any additional input parameter. Here inside the method, first I print the number of shopping items in the shopping list. And now I use a for loop over self.items to print each of items. So here I say for item in self.items, print item.title and item.quantity. Perfect. The definition for both classes is complete. Now let's create another file named main.py and use these two classes. In the left sidebar menu, here click on the new file icon and type main.py. In this file, to be able to use the classes we have defined, first we have to import them. To do so, I say from shopping list with lower s, which is the name of the file, import shopping list with capital S and product with capital P. Now let's create a new shopping list. To do so, I say list1 equals shopping list. And as you see, we need to pass a title to the shopping list constructor. Here I say, for example, grocery. Now let's print the shopping list and also call the show method for this shopping list to see if it works correctly or not. So here I say print list1 and then I call the show method for list1. And now let's run the code and see the output. As you see, our shopping list is printed correctly and it says there is no product in it. Okay, now let's add some products to our shopping list. First, we have to create some products. For example, product1 equals product. And now, as you see, I have to pass title and quantity. For example, tomato and 2. And the other one, product2, is 1 milk. And the third one is to bread. Now we can add these products to the shopping list using add method. To do so, I say list1.add and then I pass product1. And similarly for product 2 and product 3. Also, let me add, for example, a string to the list to see what happens. For example, I say list.add and then instead of passing a product, I pass a string, for example, banana. Now let me print the list, and also I want to see all the products in the list, so I call show method for the list. Okay, now let's run the code and see the result. As you see, everything works well. The first 3 products are added to the list, but the last one was not a product, so it's not added to the list. Also, as you see, the show method works well, and it prints the product correctly. In this video, which was the last video of chapter 1, you learned how to create a class that uses another class in it. I hope this video helped you better understand object-oriented programming. However, don't forget that mastering this subject requires a lot of practice. Now please go to the assignment section and solve the assignment related to this video. One of the powerful features in object-oriented programming is inheritance, and in this chapter we will talk about this in detail. Inheritance is the procedure in which one class inherits the attributes and methods of another class. The class whose attributes and methods are inherited is known as parent class or superclass, and the class that inherits the attributes from the parent class is the child or subclass. The interesting thing is that along with the inherited attributes and methods, a child class can have its own attributes and methods. In this video, I will talk about class inheritance, and to better explain the concept of inheritance, I decided to define a new problem. Suppose you want to design and implement a software like Paint in Windows. If you take a look at the menu in Paint, you see several different shapes in shapes group, such as a square, rectangle, circle, and many others. In implementation of such application, you can consider each of these shapes as an independent object. But the reality is different. Although these shapes are different, they have some shared attributes. They have a location on canvas, they have a filling color, border thickness, and so on. So instead of considering each of them as an isolated object, it's better to have a parent class with some basic and shared attributes and methods, and some child class which inherits from the parent class. By the end of this video, you will be able to create a new class that inherits from an existing class. Now let's jump into code and see inheritance in Python. Before everything, let me create a file named shape.py in which we will define our classes. So I click on Explorer and then on New File icon, and here I enter the name of the file. Also, let me create another file named main.py in which we will import our classes and use them. Well done. Now let's start by defining our classes in shape.py. As we discussed earlier, I want to define different classes for different shapes. But we saw that different shapes have some shared attributes and methods, and it's better to have a parent class that shares the attributes and methods that are common among different shapes. Usually it's better to begin with defining the parent class. So first, let's create the shape class. To do so, I say class shape with capital S to follow the convention, and now I define the $init method and I pass the self as the first parameter. For now, here assume that a shape object has 3 attributes: border color, border thickness, and location on the canvas. So I pass these 3 attributes to the init method. And now I have to assign these parameters to the self. Here I say self.borderColor equals border color, self.border thickness equals border thickness, and self.location equals location. Okay, now let's define the $str method for the shape class. For this, I say def$str and then I pass self as the parameter. And inside, I have to return a string object. This string includes the name of the class, which is shape, and the values for attributes. So I add self.borderColor, self.border thickness, and self.location. Also, suppose that we would like to be able to change the border color. So I define a method named changeBorderColor, which takes self and a color as parameters. And inside this method, I set the self.borderColor to color. You can also define another method for changing the border thickness as an exercise. At this point, our shape class is ready, and now let's go ahead with creating a new class for representing circles. So just like before, I define a new class named circle with capital C, and here is the difference. Because I know that a circle is a kind of shape and it shares the shape attributes, I enter a pair of parentheses here, and inside the parentheses I enter the name of the parent class, which is the shape. And this means that circle class inherits everything from the shape class. The shape class here is called parent class, or superclass, or base class. On the other hand, the circle class, which inherits everything from the shape class, is called child class, subclass, or derived class. For now, I just enter pass in the body of the circle class and leave it without any code. Just with this single line of code, our circle class is ready to use. Although we haven't defined any method for this class, because it inherits from the shape class, it has a copy of the methods and attributes of the shape class. Now let's go to the main file and create a circle object. Before creating a circle object, first we have to import the circle class from shape.py. So I say from shape with lower s, which is the name of the file, import circle with capital C, which is the name of the class. And now we are able to use the circle class. Here I define C1 as an object from circle class. And as you see in the parameter hint window, I have to pass 3 attributes: border color, border thickness, and location. Here I pass blue for border color, 3 for border thickness, and finally a tuple of 2 and 3, which is the location in 2D canvas coordination. Note that here, because we didn't define the init method for our circle class, when we create a circle object, the init method of the shape class is called. And this is why we have to pass these 3 attributes for creating a circle. Now I would like to print C1 to see everything is okay. Again, note that although the $$ method is not defined for the circle class, because it has been defined for its parent, we can print a circle object. Also, we can access change border color for C1. If I type C1 following by a period, you can see this method in the list of suggestions. Here, for example, let's change the color to black. And now let's print it again and run the code to see the output. As you see in the terminal, our circle object works without any errors. At first, the circle is blue, and after changing the color, it is black. The only problem with the output is that it says the object is shape, not a circle. And if you take a look again at the str method of the shape class in shape.py, you see this is because here we explicitly said that this is a shape. To fix this issue, I replaced shape with a more general statement. To get the name of the class for the self object, I can say self.dunder_class_dunder.dunder_name_dunder, and this returns the name of the class for the self object. And if I go back to the main.py and run the code, you will see that this time it says it's a circle, not a shape. To this point, the circle class is nothing but a copy of the shape class. It has no attributes or methods of its own. But as you know, in the real world, a circle has a fundamental attribute, which is its radius. So we have to define radius as an attribute for our circle class. To define a new attribute, first we have to define the init method for the circle class. So let's go to the shape.py, and here inside the body of the circle class, I define the init method and I set self as the first parameter. Here I rewrite the init method for the child class. When we rewrite a method for the child class, we say we override that method. In fact, method overriding in object-oriented programming is a feature that allows the child class to provide a specific implementation of a method that is already provided by its parent class. When we override a method for the child class, the parent method is no longer applicable. To see what happens under the hood and make it clear for you, let me just pass here inside the init method and go to the main.py and rerun our code and see what happens. As you see, we got an error. The error says the init method takes one positional argument, but 4 were given. But what is the reason behind this error? The reason behind this error is that this time we have the init method for our circle class. If I go to the shape.py here, you can see that init method for the circle class just has one parameter. But here in the main file, we are passing 3 arguments to the init method, and including self, we are passing 4 arguments. And this is why the Python says the init method takes 1 argument, but 4 were given. This shows us that after overriding the init method of the parent class is no longer applicable. So now let's go ahead and complete the init method for the circle class. Here I have to pass the parameters I need to create a circle. I need radius, border color, border thickness, and location. And now I have to assign these parameters to the self. Here I say self.borderColor equals border color, self.border thickness equals border thickness, and self.location equals location, and self.radius equals radius. If you take a look at the init method of the parent class, here you can see that these 3 lines are repetitive. We have the same lines here inside the init method of the shape class. So instead of these 3 lines, I call the init method of the shape class. So I replace these 3 lines with this statement. Super, open and close parentheses, dot, dunder, init, dunder, and open and close parentheses. In this statement, super points to the super class, which is the shape class. And now I have to pass required arguments to the init method. The init method of the shape class requires border color, border thickness, and location. So I pass border color, border thickness, and location to the init method of the shape class. At this point, our circle class has its own init method. Let's go to the main.py and rerun our code and see what happens. As you see, I got another error, and this is because when we are creating a circle, we have to pass a radius as the first argument. So here I pass 10 as radius. And now let's run the code again. As you see, this time we didn't get any error, but the problem is that when printing a circle, we can't see the radius for a circle because the circle object doesn't have its str method. So let's go to the shape.py here and define our str method for the circle object. Here I say def dunder str dunder, and I pass self as the first parameter, and again inside the str method I have to return a string object. The story for defining the str method is very similar to the story of defining dunder init dunder method. Here again, instead of writing repetitive codes, I call the str method of the super class. Here I say super.dunder str dunder, and I also add radius to this string. And now let's go to the main.py and rerun our code. Well done. As you see here, the radius is printed for the circle object. Now let's go to the shape.py and define another method to calculate the area of the circle. To do so, I define a method named area with self as the first parameter. And inside this method, it should compute and return the area of the circle. Because I need the value of pi, let me first import the mass library. So here at the beginning of the file, I import mass. And now I return mass.py times self.radius to the power of 2. Okay, now let's go to the main.py and here print c1.area. And if I run the code, you can see that the area for the circle is printed here. In this video, you learned what inheritance means and how to create a child class that inherits from a parent class. Now please go to the assignment section and do the assignment for this video. In the last video, you learned how to create a class that inherits attributes and methods from another class. But sometimes the child class inherits from multiple parent classes. For example, suppose we have 3 classes, A, B, and C inherits from A and B. Suppose that both parents have a method with similar name. The most common case is the init method. In this picture, both parents have a method named $init$. In this situation, the first question is which of these two methods will run when a child calls the init method. This is a concept called MRO, or method resolution order, which I'm gonna talk about in this video. In this video, first I show you how to create such a class that has multiple parent classes, and then we will see what happens when child class calls the method that is inherited from multiple parent classes. So let's start and jump into code. Let's start by creating a class named A, and I only define the init method for this class. This method takes self as the only parameter, and it prints a message like this inside of A. Okay, the definition of the A class is done. Now let me define another class named B that inherits from A, and inside this class I just say pass. Well done. Now let's create A1 as an object of type A and run the code to see the result. What happened here? When we create A1, the Python says a new object of type A is being created. So I have to look for the init method of the A class. And because we have defined the init method for the A class, it will be executed and you see the message inside of A in the output. Now let me change it to B. This time I create an object named B1 of type B. And now let's run the code. Again, you can see that inside of A is printed in the terminal. In the execution time, the Python says a new object is being created from class B. So I have to run the init method of the class B. If it finds the init method, then it executes the method. But what will happen when it doesn't find the init method? Should it return an error? No. In this case, Python looks for the init method of the parent class. In our case, the parent class is A, so it executes the init method of A class. This is why it prints inside of A when we're creating an object of type B. Now let me show you something surprising. Here I define a class named C, and it doesn't derive from any other class. And inside the body of the class, I just say pass. And now let's create an object of type C. Here I say C1 is an object of type C. Now what will happen if I run the code? At the time of creation of C1, Python looks for the init method of the class C, and it can't find such a method. So it looks for any parent class, but there is no any parent class for class C. So it seems that Python should return an error. Now let's run the code and see the result. As you see, Python executes the code without any error. But what happened here? The reason is that all classes in Python inherit from a special empty class called object. In other words, when you define a class, for example, the C class here, it's actually like this. It inherits from object class, and the object class is an empty class that has an empty init method. So when we create an object of type C, Python runs the empty init method of the object class. This is the reason that Python does not return any error in our program. To make sure, here I can print the parent class for the C class by saying C, the capital C, which is the name of the class, dot $, base $. This returns the base or parent class for the C class. And if I run the code, you will see that in terminal it prints object as the base class for the C class. Now let's move on to the more advanced topic, which is inheriting from multiple classes. Here I want to define 4 classes, but before that, let me delete all these lines. The first one is class A, and the init method of class A takes self as the parameter, and it prints the message inside class A. And now let me make 3 copies of class A. The second class is B, and it inherits from class A, and I change the message here to inside class B. The third one is C, and again this inherits from the A class, and also let me change the message to inside class C. And the last one is class D, which inherits from two classes. It inherits from B and C, and it does not have any init method. So I enter pass inside this class. The important and new concept in this example is that D has two parents. Now let's create D1 as an object from the D class. What do you expect to see in the terminal if I run this code? As you see, D does not have its own init method. When creating object, Python goes to the parent classes. It goes over the parent classes one by one from left to right. Here, the first parent class is B. So the Python executes the init method of B. Now let's run the code and see the output. As you see in the terminal, the message inside class B is printed. But why? As you see, D does not have its own init method. When creating object from class D, Python goes to the parents classes. It goes over the parent classes one by one from left to right. Here, the first parent class is B. So Python executes the init methods of the B class and it prints inside class B message in the terminal. And if I change the order of parent classes here, can you guess the output? Let's see the result. This time, because the left parent class is C, the init method of the class C will be executed when an object is created from the D class. You can see inside class C message in the terminal. Now let me change the scenario. First, let me change the order of classes here, and I also remove the init method for class B and I just say pass. Now let's run the code and see the output. In this case, when creating D1, Python goes to the D class. The init method is not defined for D, so it goes to B class as the left parent class. But the B class does not have its init method. Now there is two options. We can go to the parent of B, which is A, or we can go to the next parent of D, which is C. And in Python, because the searching for a method is based on the first search, it goes to the next parent of D, which is C. The C class has its own init method, so Python executes the init method for C. And as you can see in the terminal, the inside class C message is printed. The searching for a method in Python is called MRO, which is abbreviated for method resolution order. In this video, you learned what happens when a class is inherited from multiple classes. And in the next video, I will show you how Python accesses attributes when one class has multiple parents. In the last video, you saw how Python calls the method for a class that is inherited from multiple classes. In this video, I want to talk about the same process but about accessing attributes. For example, suppose we have three classes, A, B, and C inherits from A and B. As you see, the X attribute is defined in both A and B class, so it is inherited by C as well. But the question here is what the value of X is for the C object. In this video, I will show you how attributes are accessed in multi-inheritance. The process is the same, so this is a short video to just show you what happens in this situation. So let's get started and jump into code. First, let me create a class named A and define the init method for this class. Now let's define X as an attribute and set it to 10. Also, I create a class named B that inherits from A. So in the init method, it calls the init method of the superclass. And it has attribute named Y that is set to 20. And the third class is C that inherits from A. So again, it should call the init method of the superclass. Also, I define Y as attribute and set it to 40. And finally, I define a class named D that inherits from B and C, and inside its init method, it calls the init method of the superclasses. Okay, now let's define D1 as an object of D class. Because D1 is from D class that inherits from B and C, it inherits Y attribute from B and C. Also, because B and C inherits from A, they have attribute X that is inherited by D as well. So here, let me print each of these attributes for D1 and see what is the value of each attribute. As you see, Y is 20. Here Python searches for y inside the D, and because y is not defined in D, it goes to the first parent class, which is B. Y is defined in B and its value is 20. So 20 is printed in the terminal. And the value for x is 10. When we access x of D1, Python looks for x inside the D class. And x is not defined inside D. So Python looks for x inside the parent classes from left to right. Python goes to B and it cannot find x inside B. Then it goes to C to see if it is defined for C, and it can't find it inside C. Now Python goes back to B as the first parent and then search for x inside the parents of B, which is A. And finally Python finds x here and it prints the value of x, which is 10. Now let's make some changes in the definition of these classes. Here in the B class, I rename the attribute y to w and print the value of the w here. Now what are the expected values of x, y, and w if I run the code? Let's see the result. This time when accessing d1.x, again x is inherited from A class, so it is 10. For the y attribute, because it's not defined for the D class, Python looks for y in the parents of D class. Y is not defined in B, so it goes to C, and inside C it finds the y attribute that is set to 40. So 40 is printed here. And for W again, it inherits from B and 20 is printed here. As you see, when an attribute is not defined in a class, Python looks for the attribute in its parent classes from left to right. And if the attribute is not defined in parent classes, Python goes to parents of parents class. Comparing to the last video, we can see that the process of accessing methods and attributes are the same. In this video and the previous video, you learned how Python manages accessing to attributes and methods when one class is inherited from multiple classes. In the next video, you will see a new concept called abstract class, which is useful functionality in object-oriented programming in Python. Hi, in the previous videos of this chapter, you learned the concept of inheritance. In inheritance, we have a parent class that all child classes inherit attributes and methods from this parent class. Sometimes there is a method which is shared by all child classes, but each child class has its own implementation for this method. For example, here we have three shapes, including rectangle, circle, and a square. You decide to define a parent class which is the shape. Also, suppose you would like to have a method named area which calculates the area for each shape. In one hand, because this method is a shared method, it should be defined inside the shape class, which is the parent class. But on the other hand, because each child class has a different formula for computing the area, each child class should have its own implementation for this method. In this situation, we have two solutions which I'm gonna show you in this video. The first solution is raising not implemented error, and the second one is using abstract classes and methods. Now let's jump into code and see it in action. Suppose that we want to define two classes representing rectangle and circle. Because these two classes have some shared attributes and methods, I decide to define a superclass named shape. Here I define the shape class, and the init method of this class takes self and color as parameters and set self.color to color. Also, suppose that child classes must have an important method named area which calculates the area of the shape. Because all subclasses should have this method, this is a shared method. So I define this method in the parent class. So here I say def area and I pass self as the parameter. And because the implementation of this method is different for different child classes, I mean the formula for calculating area is different for a circle and rectangle, I have to enter pass here and let the child classes to define their own implementation of this method. Also, I define another method that returns the color of the shape. Here I define getColor method that takes self as the only parameter and return the self.color as output. In this class we defined two methods. The The area method is a shared attribute, but it should be implemented by the child class. But the getColor method is a method that its behavior is fixed and is the same for all classes, so the implementation of this method goes to the parent class. Okay, now let's define two child class. The first child class is circle. It inherits from the shape class, and the init method of the circle class takes self, color, and radius as parameter. And inside this method, first I call the super.dunderInitDunder method, and here, because the init method of the super class needs a color, I pass the color to this method. And then I set self.radius to radius. Also, let me create another child class named rectangle that inherits from the shape class. The init method of this class takes 4 parameters: self, width, height, and color. Inside the init method, first it calls the init method of the superclass and it passes color to this method, and then it sets self.width to width and self.height to height. At this point, although we haven't defined area method for the child classes, we are able to create a circle and rectangle object and use them. For example, here I define C1 of the circle class, and as the parameter hint window shows, I need to pass color and radius to create a circle. Here I pass red and 10. Also, I define R1 equals rectangle, and then I have to pass width, height, and color, and I enter 2, 3, and blue. And now let's investigate the behavior of these two objects. Here, if I type C1 and then type dot, you can see a list of attributes and methods for the circle object. It has 2 attributes, color and radius, and 2 methods, getColor and area. As I said, although we haven't yet defined the area method for the circle and rectangle class, here we can call this method for C1 and R1. Here I print area and C1.area, and also let me print area and R1.area. And now I run the code to see what happens. As you see, the code runs without any error, but the result is none, because we haven't defined the area method for the circle and rectangle classes. The problem here is that we want to force the child class to implement the area method for itself. In other words, I'm searching for a way to prevent the user from calling area method when it's not defined. So how can we fix this issue? There are 2 solutions for fixing this issue. The first solution is to raise an error when the area method is not implemented by the child class. Here, in the parent class, inside the area method, I raise not implemented error. And to make the error message more clear, here I pass a message like this: area method is not implemented for self.dunder_class_dunder.dunder_name_dunder. And now let's run the code and see the result. This time, as you can see, the program execution stopped with an error, and the error says area method is not implemented for circle class. Also, if I go to the code and comment the line 26 and run the code again, you can see that the error message has changed. This time, the error message says area method is not defined for rectangle. As you can see, in our first solution, the circle and rectangle class can be instantiated, but the created object cannot call the area method. Now let me show you the second solution. We can force any classes that want to inherit the shape class to implement the area method before instantiating. The other solution is defining abstract classes and abstract methods. In object-oriented programming, an abstract method is a method without any implementation. Here, in our example, the area method in the shape class can be considered as an abstract method. When a class contains one or more abstract methods, then it is called an abstract class. Now let me show you how to define an abstract class and abstract method. Unlike other programming languages like Java, Python by default does not provide abstract methods or abstract classes. but it does offer a module called ABC that allows us to define abstract classes and methods. So first of all, we have to import ABC in our code. We usually import ABC like this: from ABC, import ABC, all capitals, and abstract method. ABC with capital letters is the abstract base class that all abstract classes should inherit from this base class. So here our shape class should be derived from ABC. Then to define a method as an abstract method, we have to use the abstract method decorator. For example, here to define the area method as abstract method, in the previous line I add @abstract method. That's it. Now we no longer need this raise statement. So again, I comment this statement and say pass. Now let me run the code and see what happens. Now let me uncomment this line and run the code to see what happens. As you see this time, I got an error that says cannot instantiate abstract class circle with abstract method area. It means we cannot even create a circle object without defining area method for the circle class. We have to force to define the area method for the circle class to be able to use it. So let's go to the circle class and override the area method for this class. Here I say def area and I pass self. And inside this method it should compute and return the area of the circle. To calculate the area we need pi, so we have to import mass library. Here at the beginning of our code I import mass. And now in the area method I return mass.pi times self.radius to the power of 2. Now let me run the code. This time the error is related to the rectangle class. It says cannot instantiate abstract class rectangle with abstract method area. So we have to implement area method for rectangle class too. Here inside the rectangle class, I define the area method again. And it returns self.width times self.height. And now we can run the code. As you see, everything works well. And the area for the circle and rectangle are printed here. As conclusion, when you want subclasses to have their own implementation of a shared method, we have to define that method as abstract method in the parent class. And therefore, in this case, we have to declare the parent class as abstract class. In this video, which was the last video of chapter 2, you learned the concept of inheritance and abstract classes in Python. Now you can go to the assignment section and do the assignment for this video. So far, every time we talked about attribute, we meant instance attribute. But in this video, I will talk about a class attribute that is a property of a class, not an object. In object-oriented programming, when we create a class, we define some attributes that describe the objects. For example, here, the A class has two attributes, X and Y. When we create objects of this class, each object has its own values for these attributes. For example, here, the X attribute for object 1 is 1 and is 10 for object 2. This is why we usually refer to these attributes as instance attributes or object attributes. While in most situations when we talk about attribute, we mean instance or object attribute, there is another type of attribute that describes the class itself. The class attribute is an attribute of the class and all objects have the same value for this attribute. Here in this example, apart from the two attributes X and Y, which are instance attributes, there is also an attribute named Z, which is a class attribute. And therefore, all objects instantiated of this class have the same value for this attribute. In this video, I will show you how to define and use class attributes in Python. So, let's jump into the code. Consider the bank account class as example. This is the first class that we created in this course. Here, I define a class named bank account, and the init method takes three attributes including account number, holder, and balance. And then inside the init method, I set self.number to number and self.holder to holder, and self.balance to balance. These attributes are called instance attributes or object attributes because they have different values for different bank account objects. I mean, my bank account number is different from your bank account number, or my balance would be different from your balance. Now let's create another attribute named interest rate, which is the same for all bank account objects. This attribute is a bit different from those three previous attributes. Because the interest rate is the same for all bank accounts, it's not an attribute for objects. It's actually a class attribute. To define a class attribute inside the class and before the init method, we should initialize the class attribute. Here I set interest rate to, for example, 1.5. And now let's create ACC1 as an object of bank account. And I pass 1, 2, 3 for account number, Alex for holder, and 20 for balance. And now let's access the interest rate attribute. Outside the class, we can access the class attributes in two ways. The first and more reasonable way is to access class attribute through the name of the class. Here I say print bank account, that is the name of the class, following by period, and then access the class attribute, interest rate. And the other way is accessing a class attribute like an instance attribute. Here I can say print acc1.interestRate. However, it's usually better to use the first method because it makes more sense to access a class attribute through the name of the class rather than an object. And I also want to create another bank account object named acc2 with 234 as account number, Bob as holder, and $10 as balance. And then I print interest rate for this object. And now let's run our code and see the result. And as you see in the terminal, each of these three print statements print the same number in the terminal. Now let me show you something interesting about class attributes. Because class attribute is shared between all objects, if you change it anyway in your code, it influences other objects as well. For example, let me change the interest rate to 2.5. So here I say bank account.interestRate equals 2.5. And then I print bank account.interestRate, acc1.interestRate, and acc2.interestRate. And if I run the code, you can see after I changed bank account.interestRate, the interest rate for both objects has changed. Now that you learned how to use a class attribute outside of the class, let me give you an example to show you how you can use class attributes inside the class. Suppose that we want to have a method named calculateInterest, which calculates the interest for 1 month. So here I define a method named calculateInterest and then pass self to this method. And inside this method, I define interest equals to self.balance times bank account.interestRate. And finally, it returns the interest. And now let's use this method. Here at the end of this code, I print acc1.calculateInterest and print acc2.calculateInterest. And if I run the code, you can see it prints $50 as interest for account 1. It's because the interest rate is 2.5 and the balance for account 1 is $20. So 2.5 times $20 makes $50 as interest. And the interest for account 2 is $25. Another common use case of class attribute is keeping track of the number of objects that has been created from a class. For this purpose, first I create a class attribute named population here, and I set it to 0. And then inside the init method, I increase the population by 1. It means whenever a new object is being created, this attribute increases by 1. Now let's print bank account.population at the end of this code. Here I print bank account.population. And if I run the code, it prints 2, which means that 2 bank account objects have been created to this point. In this video, you learned what a class attribute is and how it is different from an instance attribute. Now you can go to the assignment section and do the assignment for this video. Hello and welcome back to the second video in chapter 3. In the previous video, you saw that two types of attributes can be defined within the class: class attributes and instance attributes. In this video, I will talk about methods. There are three types of methods that you can define inside your classes: instance methods, class methods, and static methods. You are already familiar with instance methods. In fact, all the methods that you have seen before in this course were instance methods. If you develop an intuitive understanding for their differences, you will be able to write object-oriented codes that will be easier to understand and maintain. So let's get started and jump into code. To better understand the difference between instance method, static method, and class method, I begin by writing a simple class that contains simple examples for all three method types. Here, I define a class named sample class. I would like to have a class attribute for this class. So here I define a variable named x and I initialize it with 0. And then I define the init method that takes self as parameter. This class has one attribute named y that I set it to 10. As I told you, I want to define three methods with three different types. So let's start by defining an instance method. Here I define a method named changeObject. This method is like any other previous methods that you have learned. So it takes self as first parameter and we can pass any other parameters as well. In this case, I pass a new value for x and new value for y. It is clear that because the instance methods take self as parameter, they have access to the object. Therefore, they can freely access attributes and other methods on the same object. And this gives them a lot of power as they are able to modify the object's state. So here I can print the attribute y for this object. Or I can set a new value to y by typing self.y equals new y. Inside the instance methods, not only I can access object, but I can also access the class itself through the $class attribute. Here I can print class, comma, self.class. Or I can access the value of class attribute x by typing self.class.x. And let me add a message to make it more clear in the terminal. Here I type the class attribute. Apart from accessing to class attributes, we can also assign a new value to class attributes. Here I can say self.class.x equals new x. Okay, now let's use this method in action. Outside the class, first, as you know, the class has a class attribute, and here I want to print the value of x. So I type the name of the class, which is sample class, followed by the name of the class attribute, which is x. And again, let me add a message before printing this value. Now let me create an object named obj of the sample class. And now I can call changeObject method for this object. So I say obj.change_object, and I have to pass a new value for x and a new value for y. And finally, let me again print the class attribute x and the instance attribute y again. So I print class attribute x and sample class.x and print instance attribute y obj.y. And now let me run this code. As you see in the terminal in the first line, it prints 0 for class attribute x and it prints 10 for y attribute for the object. And inside the class we printed the name of the class, which is sample class. It shows that inside the class we can access the name of the class and the class itself. In the next line we have printed the class attribute x, which is 0. These three lines of outputs are printed inside the changeObject method. And after calling this method, the class attribute x has changed to 50. and also the instance attribute has changed to 100. This tiny example shows you that instance methods can freely access and modify the object and class states. Now let's move on to the next types of methods, which are the class methods. Here inside a class, I define a new method named change_class. And instead of accepting self as parameter, class methods take CLS parameter that points to the class. They can also take other parameters as well, and there is no any limitation in parameters, but in this case I don't want to pass any other parameters. In order to tell Python that a method is a class method, not a regular instance method, we need to mark the method with class method decorator. So in the previous line, I add @class method. As you can see, because class methods doesn't take self as parameter, they can't modify the state of object instance. As a result, I cannot say, for example, print self.x, because self is not defined inside this method. Class methods can only modify the class attributes that are shared across all instances of the class. To access a class attribute, I can use CLS that points to the class. Here, let me print the value of x, which is a class attribute. To this end, I say print class attribute x, and then to access x, I can say cls.x. I can also change the value of x by typing cls.x equals, for example, 1000. Now let's go outside of the class and see how we can use this class method. First, let me comment all these lines. Unlike instance methods, we don't need to create an object to call a class method. Class methods can be called directly from the class. So I can type sample class, which is the name of the class, dot change_class. And I would like to print the value of x before and after calling this method. So here in the previous line, I print class attribute before the call sample class.x. And now let me copy this statement and paste it in the next line and change before to after. And now let's run this code and see the result. As you can see in the terminal, before the call, the class attribute is 0. And inside the class, I print the attribute x, which is 0 again. And then after the call, the class attribute is 1000. This example shows us that class methods can only modify class attributes, so they are less powerful than instance methods. Now let's go ahead with defining a new method, which is a static method. Inside the class, I define a method named auxiliary method, which is going to be a static method. Static methods take neither a self nor a CLS parameter, but of course it's free to accept an arbitrary number of other parameters. But for now, I want to leave it without any parameters. Like class methods, we have to tell Python that this method is not a regular instance method. To do this, we mark this method with static method decorator. Inside this method, because it doesn't take self or CLS as parameter, it can neither modify object state nor class state. Static methods are the least powerful methods in the class. They can be seen like tools or auxiliary methods that are called by other methods in the class. Here I just print a message that shows it is inside the method. Now let's go outside of the class and see how we can call this method. Outside the class, static methods can be accessed through both objects and the class. First, let me comment these lines, and here I can say sample class.auxiliary method. Or I can also create an object, for example, obj equals sample class, and then I call auxiliary method for this object. Now let's run the code and see the result. As you see, we got the same result in both approaches. As conclusion, there are three types of methods inside the class: instance methods, class methods, and static methods. Instance methods are the most powerful methods because they can modify objects and class attributes. Class methods can just access and modify class state, so they are less powerful than instance methods. And finally, static methods, which are very limited and cannot modify object or class attributes. Note that because instance methods are more powerful than class methods and static methods, we can replace any class method and a static method with an instance method. But to make our code easier to communicate and also easier to maintain, it is better to use the most proper method in each situation. In the next video, I will show you the use case of a static method and class method in a typical application. Hello and welcome back. In the previous video, you learned that there are three types of methods in Python: instance methods, class methods, and static methods. While in most of cases you define instance methods, but in this video I will show you the use cases for the two other methods. So let's jump into code and see when we can use class methods and static methods. Consider a class named developer that each developer has three attributes, including name, age, and a set of skills. So I define the developer class, which its init method takes two parameters, name and age. And it sets self.name to name, self.age to age, and self.skills to an empty list. Also, let me define the str method for this class. So here I say def $str$, which takes self as parameter. And the str method returns a formatted string. This string contains the name of the class, which I can explicitly say developer, or I can say self.class.name. And then it shows the name of the developer, self.name, the age, self.age, and finally it shows the number of skills for the developer, the length of self.skills. Okay, we also need to have a method for adding a new skill to the developer. So here I define a method named add_skill that takes self and a skill. And I append the skill to self.skills and print a skill added successfully. But suppose that the number of skills for the user is limited to, for example, 3. It means that the user cannot have more than 3 skills. So here, before appending the skill to self.skills, I say if length of self.skills is less than 3, then append the skill to self.skills. Otherwise, I print you cannot add more than 3 skills. Here, number 3 is a constant, and instead of saying like this, it's better to define it as a constant. The best way for defining a constant for a class is defining constant as class attributes. So here, before the init method, I create a class attribute named limit, and I set it to 3. And now, instead of saying 3, I enter developer.limit. Also inside the print function, I replace 3 with developer.limit and I format the string. Now suppose that in some situation, for some reason, we want to change the limit attribute. For this purpose, I define a method named setLimit. Because this method just wants to change the value of the class attribute, it doesn't need self. So we can define it as a class method. So I mark this method with class method decorator. And instead of self, I pass CLS as parameter. Also, it gets the new limit value as input parameter. And inside this method, I set developer.limit to limit. Okay, the definition of our class is complete. Now let's go ahead and create an object from this class. Outside of the class, I define d1 equals developer, and I should pass a name and age for this developer. For example, here the name is Jennifer and she is 20 years old. Also, let me add some skills for this developer. To add a skill, I call the add_skill method and I pass, for example, Python. The next skill is Java. Also, she knows C++. Also, she can code in MATLAB. Now let me print D1 and run the code to see what happens. As you can see in terminal, the first 3 skills has been added successfully to the developer, but the last one is not. And printing this object says it's a developer, her name is Jennifer, she's 20 years old, and she has 3 skills. To be able to add 4 skills to the developer, before adding the last skill, I have to set limit to 4. So here, before this line, I say developer.setLimit and I pass 4. And now let me run the code again to see what happens. Now, as you can see in terminal, Jennifer has 4 skills. Now let me show you the second use case for class methods. If you take a look at the init method, you see that we have to pass the developer's name and age to create a developer instance. Assume that for some developers, instead of their age, we have their birth year. And we would like to be able to create a new developer using their name and their birth year. For example, I would like to create a new developer like this. D2 equals developer Alex and his birth year is 2000. Regarding to our code, this means that Alex is 2000 years old, and it's obviously wrong. In this situation, we need to have a new way for creating an object. This is the second use case of class methods called factory method. So inside a class, I define a new class method named FromBirthYear. This method should be a class method. So I add class method decorator, and instead of self, I set CLS as the first parameter. Also, I need a name and a birth year as parameter. Because this is a factory method, it should create a new developer and return it. But before creating a new developer, first I need to convert birth year to age. To this end, I need to import datetime library. So in the first line of our code, I say from datetime import datetime. And here, to get the year for this year, I say year equals datetime.today.year. And now I create a new developer by saying developer, and I pass name, and the age is year minus birth year. And instead of developer, I can also say CLS, because CLS in class method refers to the class. And finally, I return this new developer. Now, outside of the class, instead of a normal way for creating a developer object, I use the factory method. So I call FromBirthYear and I pass attributes to this method. And that's it. Now, like any other developer, I can add a skill to this developer. I can say d2.add_skill, for example, PHP. And now let me print this user. And by running this code, it says this is a developer, his name is Alex, he's 22 years old, and he has 1 skill. Okay, now let's see the use case of a static method. As you can see in this method, we first convert the birth year to age. Instead of here, we can define a method that do this conversion for us and use that method here. For example, let me define a new method named birth year to age. This method only takes birth year and convert it to age, so it doesn't need access to self nor class. In this case, this method is a static method and it acts like a utility method. So I mark this method as a static method. And let me move this statement from here to here, and I return year. And here I say year equals developer.birthYear to age, and I pass birth year. And if I run the code again, you can see the same result as previous. In conclusion, when you are going to manipulate class methods or when you want to create a new factory method, you need to define a class method. And if you are going to define a method which acts as a utility method, you can define it as a static method. In this video, you learned how and when you can use class methods and static methods. Now, please go to the assignment section and do the assignment for this video. Hello and welcome to assignment 1. In this assignment, you are supposed to define an object named player that is a player in Atari game. Each player has a name and a number of hearts as instance attribute. When it comes to methods, apart from the str method, the player has a method named lose. Each time player lose, the number of hearts will decrease by 1, like in a computer game. And if the number of hearts reaches 0, it prints game over. By default, the number of hearts is 3. I mean, when you create an object, the number of hearts for the object is 3. But consider a class variable named maxHeart that stores the default number of hearts for all objects of the class. Now, let me show you the behavior of the player object. First, let me create an object of player class. To create a player object, I need a name. Here I say p1 equals player, and I pass John as name. The player object has an attribute named hearts, and if I print the number of hearts for John, it says 3. Also, the player object has a method named lose, and if I call the lose method, it says you lost, but you have 2 more hearts. And if I call the lose method for 2 more times, you see it says game over. The number of default hearts is stored as a class variable named maxHeart, and as you see, it's 3. If I change this class variable, for example, to 1, from this point, all players will have only 1 heart. For example, I say p2 equals a player, and I pass Bob as name. And let me show you the number of hearts for Bob. I say p2.hearts. As you can see, it's 1. And if I call lose method only 1 time, it says game over. Okay, now it's your time to create your own player object with the same behavior. You can pause this video and try to solve the problem. Then you can come back and watch the rest of this video. Well, before everything, I have to define a class named player. Each player has a name and number of hearts. Because the default value for number of hearts is 3, I don't take it as parameter in the init method. So the init method just takes the name of the player. And inside the init method, I set self.name to name and self.hearts to 3. Also, to be able to print the player, let me define the str method. I want to report the name and the number of hearts. And finally, as the problem says, the player may lose. So it's a behavior and I define a method named lose. This method takes self as parameter. And inside this method, I check if self.hearts is greater than 0, then self.hearts minus equal 1, and it prints you lose, but you have self.hearts more hearts. Otherwise, I mean when no heart is left, it prints game over. And now let's define one player. Here I say player equals player, and I pass John as name. And I print the player to see how many hearts it has at first. And then I'm going to call lose method 4 times to see what happens. And now let me run the code to see the result. As you see, at this time everything works well. But the problem says the default value for hearts should be considered as a class attribute. So before the init method, I define a class attribute named maxHearts and I set it to 3. And here in the init method, instead of 3, I say player.maxHearts. And now let me run the code again. As you can see, the result is the same as previous and everything works well. Suppose that you have a shopping list class that takes a list of items in time of creation. For example, I can say list1 equals shopping list, and I can pass a list of items such as banana and milk. And this shopping list has an attribute named items that contains shopping items. And here I can print items for this shopping list. Also, there is an alternative constructor named fromString that takes a string of items. I can say list2 equals shopping list dot from_string, and I pass banana, and milk as a string. In this string, items are separated using a comma. And now, again, if I print items attribute, I can see the items. Now you know how shopping list works. It's your turn to create the shopping list class. Now please pause the video and try to create a class with such behavior. Then you can watch the rest of the video to see my solution. First, I create a class for shopping list. And the init method takes a list of items. And it sets self.items to items. Also, to create the alternative constructor, I define a method named fromString. As you know, this method should be defined as a class method. So in the previous line, I add class method decorator. And because this method is a class method, instead of self, it takes CLS. And also, it takes a text as a list of items. Inside this method, first I split the input text with comma as separator, and then I store the result in items. At this point, items is a list of strings. Now I have to create and return a shopping list object that takes items as parameters. To do so, I say CLS and I pass items to it. And finally, I return this object. Now here, outside of the class, I can create a shopping list object by passing a list like this, for example, banana and milk, or I can call fromString method from the class and I pass in a string like this, banana and milk. And in both cases, I can access items attribute and I can print it. So I say print l1.items and print l2.items. Now let me run the code to see the result. As you see, although these two shopping lists are created in two different ways, but the items for both shopping lists are the same and they are printed in the terminal. Hello and welcome to the chapter 4 of this video tutorial. This chapter will talk about one of the essential concepts in object-oriented programming called encapsulation. Encapsulation is a mechanism to wrap up attributes and methods together as a single unit and hide information details and protect the data and behavior of the object. Let me give you an example to make this clear. Imagine that you're watching TV in your house. TV is an object. It has some attributes and methods. Apart from features such as brand, size, the model, you have features to describe the status of the TV at any given time. These include the channel that you're watching and the volume. What are the behaviors? You can change the channel and you can increase or decrease the volume. Of course, you cannot change the volume by directly manipulating the TV hardware. Instead, you use the remote control to do this. In fact, the TV manufacturer has provided you with a remote control that is a way to interact with your TV. Having a remote control has two advantages. First, you don't need to deal with complex TV hardware and it hides the internal complexities of the TV set. Second, you cannot turn up the volume as much as you want. If you could increase the volume directly by manipulating the hardware, you might cause the speakers to malfunction. In this example, the volume and channel are not publicly accessible from outside. You can only change them using the remote control. This is the concept of encapsulation. Encapsulation puts restriction on accessing attributes and methods directly and can prevent the accidental modification of the data. In this video, I will talk about basic concepts in encapsulation, which are public and private attributes. And by the end of this video, you will be able to define public and private attributes in your classes in Python. So let's get started. To better explain the concept of encapsulation, let's consider the TV example and develop a class representing a TV set. Here, I define a class called TV, and after that, I define the init method with self as the only parameter. Because this is just an example for clarifying encapsulation, I don't want to consider all attributes that the TV has. At this moment, the TV has a status that might be on or off, and the initial value for TV status is off. So here I set self.status to off. Also, it has a channel that is broadcasting. Suppose that different channels have a unique number between 1 and 10, and the initial value is 1. So I set self.channel to 1. And finally, it has a volume between 0 and 100, and the initial value is 50. So I set self.volume to 50. Well done. The definition for the init method is complete. And now let me write the str method for this class so that we can print the objects. So here I define def $str method with self as the only parameter. And here I return a formatted string. And inside the string I say tv, which is the name of the class, and I list the attributes for the object. I mean status, and I put self.status in curly brackets, channel and self.channel, and finally volume and self.volume. Okay, now let's go ahead and create an object from this class. Here I say tv1 equals tv, and I don't need to pass any arguments to the class constructor. Now let me print it and run the code. Okay, it works. As you see, we have created a TV object with initial attributes. As you know, outside of the class, we can access attributes of the object. Here, I can say print tv1.volume or print tv1 channel. Also, I can set new values to the attributes, even invalid values. For example, I can say tv1.channel equals -1 or tv1.volume equals 200. And now let me run the code again to see what happens. As you can see, the values for these attributes have changed. This short piece of code shows you that the outside of the class, not only we can easily access attributes to read them, but also assign any value, including invalid value, to them. The problem is obvious. The user shouldn't be able to get and set attributes without any control. Because there is no validation check, we can assign any invalid values to the attributes, and it makes our code highly vulnerable and might cause errors. So the first thing we have to do is to stop accessing attributes from outside of the class. In other words, we have to make those attributes private. In the context of object-oriented programming, private means attributes and methods that are only available inside of the class, not outside of the class. In some other programming languages, such as Java, a special keyword named private makes an attribute private. But in Python, the story is entirely different. In Python, there is no way to make an attribute absolutely private. In Python, by convention, if an attribute's name starts with a single underscore, it tells other programmers that it is a private attribute. For example, if I add a leading underscore to these attributes here for status, channel, and volume, it signals other programmers that these attributes are private. It's just a convention and doesn't do anything in practice. Let me update other parts of the code inside the class. Here, here, and here, and also outside of the class, here, and run the code to see what happens. As you can see, still I can read attributes and set invalid values to them. So one leading underscore is just a warning signal and doesn't stop others from accessing attributes outside of the class. The second solution is to start the name of attribute with double underscore or dunder. If you use a double leading underscore for attributes, the value is no longer normally accessible from outside of the class. Let's try this one. Here I add another underscore to the beginning of each attribute. And also I have to update the other parts of the code. For now, let's just focus on reading attributes outside of the class. So let me comment these two lines. And if I run the code, as you can see in the terminal, it raises an error. The error says TV object has no attribute underscore volume. Although we do have an attribute with this name, it says there is no attribute with such a name. What happened here? To see all attributes and methods of an object, we can use dir method. Here, after creating tv1, let me print tv1.dir and see what happens under the hood. As you see, when you start an attribute with double leading underscore, Python changes the name of the attribute in a strange way. It adds underscore following by the name of the class to the name of the attributes. Here, underscore underscore status has been changed to underscore tv underscore underscore status. Or underscore underscore channel has been changed to underscore tv underscore underscore channel. So it is obvious that I can still read the attributes with their new names. Here, let me add underscore tv to the name of attributes outside of the class and again run the code to see what happens. As you see, again I can read the attributes. So as I told you, there is no way to make an attribute absolutely private in Python. But it's acceptable because we just want to avoid accidental errors in assigning invalid values to the attributes. Now let's assign new values to these attributes. First, I uncomment these lines. And as we know, the name of attributes has changed. So here I have to change the names. I add underscore tv to the name of attributes. Now let me run the code and see the result. As you see, again, it works and the values for attributes have changed. However, as I told you, the attributes this time are not normally accessible. Also, let me show you something surprising. What happens if I assign new values using previous names? I mean removing underscore tv here and here. As you see, this time again the code runs without any error, but the attributes have not changed. It's a bit confusing. To see what happened here, let me again print tv1.dir. And if I run the code, as you see, in attributes of the object, after assigning values, instead of changing the previous attributes, two new attributes are added to the object. In fact, there is no way to change the attributes unless a programmer intentionally uses strange names that you saw for attributes. In conclusion, to avoid invalid values for attributes, we have to make them private. In Python, if you start the name of attribute with one underscore, it's only a warning for other programmers that the attribute shouldn't be touched from outside of the class. However, it doesn't raise any error if someone doesn't follow this rule. But if you use double leading underscore in naming an attribute, it's not be accessible from outside of the class in normal way, and it raises an error if a programmer doesn't follow the rule. When we make an attribute private, we don't really want to completely restrict other programmers' access to attributes. Instead, we just want to ensure that the value assigned to attributes is valid. The following video will talk about getter and setter methods that provide a way to access private attributes. In the previous video, I told you what encapsulation means in object-oriented programming, and I gave you an example of encapsulation. As I told you in the TV example, the first step for the manufacturer is to hide the complexity of the hardware by creating a frame for the TV set. Similarly, in the previous code, when we made attributes private, we created a frame for our class that no one can see inside of the class and access attributes of the class. In the next step, the manufacturer of TV set provides a remote control for us to interact with TV. Similarly, when it comes to the classes, we have to provide a way for users to interact with objects. I mean getting attributes or setting new value to private attributes. In this video, I will talk about two types of methods called getter and setter that provide a way to get and set value for private attributes. So let's get started. Here is our code we wrote in the previous video. In this class, all attributes are private, and as you saw in the previous video, they cannot be accessed outside of the class. However, for some private attributes, we need to be able to get and set their values outside of the class. So we have to provide a way for other programmers who want to use the class to be able to interact with attributes. The solution is to define methods called getters and setters. A getter method is a very simple method that usually contains one line of code. It returns the value of an attribute. For example, here I define an instance method called getVolume, and I pass self as the only parameter. And inside this method, I just return self.dunderVolume. That's it. We have defined a getter method for the volume. And as you know, private attributes are accessible inside of the class, so there is nothing wrong with this code. We can do the same for the other attributes. Here I define another method named get_channel that returns self.__channel. And for status, I define get_status and return self.__status. Now that we have getter method for all attributes, instead of accessing private attributes like this outside of the class, we can call the getter method. So I can say tv1.getVolume to access the volume for tv1. And for channel, I can call getChannel to access the channel attribute. And before I run the code, let me remove the other lines that we don't need them anymore. Here, and also this one. Okay, now let's run the code to see the result. As you see, we can access the private attributes through these getter method. In the same way, we can define methods called setters that take a new value as an argument and assign it to the private attribute. For example, let's define a setter method for volume attribute. Here inside of the class, I define setVolume method with two arguments. The first one is self and the second one is volume, which is the new value for the volume attribute. And inside this method, I assign volume to self.__volume. Now let's go and use this method. Here I want to set volume to 200. So I can say tv1.setVolume and I pass 200. And now let me again print tv1 and run the code. As you see in the terminal, the volume has changed to 200. But as we discussed in the previous video, the problem was that we wanted to avoid invalid values for attributes. And the interesting thing about the setter method is that you can do validation checks before doing the assignment. Here, because the volume should be between 0 and 100, we have to ensure that the input value is valid. The first solution is using assert function. I say assert volume is greater than or equal 0 and less than or equal 100. And I specify the error message here. The volume should be between 0 and 100. And now let's run the code and see what happens. As you can see in the terminal, we got an error. It is an assertion error which says volume must be between 0 and 100. So we are not able to assign invalid value to volume. But if I set the volume to, for example, 90, and if I run the code again, you can see that the volume has changed to 90. The other solution is using the raise function. Here, instead of using assert, I comment this line, and in the next line I say if volume is greater than or equal 0, and less than or equal to 100, then self.volume equals volume. Otherwise, raise value error, and I set the message for the error. Volume must be between 0 and 100. And now let me set the volume to 200 again. And if I run the code, you can see it raise a value error that says volume must be between 0 and 100. And if I change it back to 90 and run the code again, the volume has changed to 90. Well done. Similarly, I define a setter method for the channel attribute. Because these methods are similar, let me copy this method and paste it here and change setVolume to setChannel and get the channel here as parameter. And let me remove this line. And because the channel should be between 1 and 10, I say if channel is greater than or equal 1 and channel is less than or equal 10, then self.__channel equals channel. Otherwise, it raise a value error and I say channel must be between 1 and 10. And now outside of the class, let's call this method. Here I say tv1.set channel to, for example, 20. And if I run the code, you can see it raise a value error that says channel must be between 0 and 10. And if I change the channel, for example, to 8 and run the code again, the value for channel has changed to 8. As you see, everything works well. Well done. In this video, you learned how to define the getter and setter method to provide a way to interact with private attributes. In conclusion, after you make an attribute private, it's no longer accessible outside of the class. To provide a controlled way to get the value of a private attribute or set a new value to it, we create getter and setter methods. The getter method is usually a simple one line of code which returns the value of the attribute. But in setter method, we usually check the validity of the new value for the attribute, and if the value is not valid, we raise the value error. So far, you learned how to define private attributes inside a class and then create getter and setter methods to access private attributes. Outside of the class, to get the value of an attribute, we have to call a getter method, which is a bit awkward. Instead, we prefer to access an attribute, like this. Also, for setting a value to an attribute, instead of calling a setter method, we prefer to use assignment operator. In this video, I will show you how to create property object which converts getter and setter methods to attributes. So let's get started and jump into code. This is the code we wrote in the previous session. As you can see, to get the value of a private attribute, we call its getter method. However, this is not what we would like. We usually prefer to access attribute using dot notation. For example, in order to access the private volume attribute, I would prefer to say print tv1 volume. Similarly, to change a volume attribute, I have to call the setVolume method, which is unpleasant. Instead, I prefer to use the usual assignment operator like this: tv1.volume equals 90. Fortunately, in Python, it's straightforward to convert getter and setter methods to equivalent attributes. In Python, a built-in function named property creates and returns a property object. The property function gets the getter and setter method and returns a property that behaves like a public attribute. To do this, inside a class, I say volume equals property, and then I have to pass getter and setter functions to the volume attribute, which are getVolume and setVolume. Here, note that I passed the name of the getter and setter methods without any parentheses. Likewise, I say channel equals property, and then I pass getChannel and setChannel methods to this function. And outside of the class, we can access private attributes using the property object. So instead of calling get_volume to access the volume attribute, I can directly say tv1.volume. Also, instead of saying tv1.get_channel, I can print tv1.channel. And when it comes to setter methods, instead of calling set_volume, I can say tv1.volume equals 90 or tv1.channel equals 8. Now let me run the code to see the result. As you can see, we can easily get and set a new value for attributes. Also, don't forget that our setter methods do the validation check for us. And here I cannot set the volume to, for example, 200. Let me try this one and run the code to see what happens. As you can see, this line of code, tv1.volume equals to 200, causes a value error. Volume must be between 0 and 100. In Python, there is one more way for implementing property function. Instead of property function, we can use decorators. To this end, First, let me comment these two lines. And then we have to mark getter and setter methods inside of the class. For a getter method, we have to add property decorator before each of these getter methods. So here, before get_volume, I say @sign property. And I copy this statement and paste it for get_channel and get_status. Also, I simplified the name of the getter methods. Here, I remove get_ from the name of the methods. And for setter methods, we have to use another decorator. The decorator for setter methods has a specific format. Here, for set_volume, the decorator starts with @sign, and then I have to enter the name of the getter method, which is volume, and then I add .setter, and then I have to remove set_ from the name of the method. So the getter and setter method here have the same name. For set_channel, the decorator would be @sign, the name of the getter method, which is channel, and then I add .setter, and I remove set_ from the name of the method. Okay, now we can run our code to see the result. As you can see, the result is the same as the previous code, and the value for private attributes has changed. And again, if I set invalid values to attributes, for example, 190 or 18, and I run the code again, you can see I get an error which says volume must be between 0 and 100. Before ending this video, let's just recap what we did in this chapter. In chapter 4, first you learned that encapsulation means limiting the access of attributes and methods from outside of the class. Then you saw how to define private attributes that cannot be accessed outside of the class. After that, in the previous video, you defined getter and setter methods for interacting with those private attributes. And finally, in this video, you learned how to convert getter and setter methods to equivalent attributes. It is noteworthy that like attributes, you can make some methods private, and the process is the same. Just start the name of the method with double leading underscore. The private methods are usually called by some other non-private methods in the class. Now, please go to the assignment folder and do the assignment for this chapter. For this assignment, I want you to create a class representing a weather condition. The weather condition has two attributes, temperature and status. Suppose that temperature is in centigrade and can be between -40 and 40. Also, the status can be one of the following: sunny, cloudy, rainy, and snowy. The weather condition can be created like this. WC, short for weather condition, equals weather condition, and I have to pass status, for example cloudy, and temperature, for example 18. It is clear that I can't create a weather condition by passing an invalid status. For example, let me say WC equals weather condition, and I pass, for example, stormy and 18. And as you can see, it says value error, status is not valid. Because as I told you, status can be sunny, cloudy, rainy, and snowy, not stormy. Similarly, I cannot say WC equals weather condition, rainy, and 60. Because it says temperature should be between -40 and 40. Now let me pass valid status and temperature to create a valid weather condition. Here I say WC equals weather condition, and I pass, for example, rainy and 18. After creating a valid weather condition, I can use assignment notation to set a new value to status and temperature. But again, I cannot assign invalid values. Here, let me say WC.status equals stormy. And if I run the code, you can see it doesn't allow me to change status to an invalid value, and it returns value error. Also, I cannot say WC.temp equals 100 because it says temperature should be between -40 and 40. Now it's your turn to define such a class that has the same behavior. You can pause this video and try to define this class, then you can resume that video to see the solution. First, I create a class for weather condition. And in the init method of this class, I pass a status and a temperature. Inside the init method, we need to validate the input arguments. So I say if status in a list of valid status, including sunny, cloudy, rainy, and snowy, then I set self.status to status. Otherwise, it raises a value error that says status is not valid. Also, if temp is greater than or equal -40 and less than or equal 40, then self.temp equals temp. Otherwise, raise value error, and the message is temp should be between -40 and 40. Because I don't want these attributes to be modified directly from outside of the class, I make them private. So I add a double underscore at the beginning of their names. Here, instead of saying self.status, I say self.__ status. Also, instead of self.temp, I say self.__ temp. Now, because our attributes are private, I have to provide getter and setter method for them. Here I define a method named status and I decorate it with property decorator. This is a getter method for a status attribute, and inside this method I just return self.__ status. Now I define another method with the same name, which is the setter method for a status attribute, and I decorate it with @status.setter. Also, because this is a setter method, I have to add another parameter for a status. And inside this method, before updating a status attribute, I have to do validation check. But because I have done validation check inside the init method, I just make a copy of these lines and paste it here, and that's it. Now let me make a copy of these two methods to define getter and setter method for temp. Here first I change the status with temp, also here, and instead of saying __ status, I say __ temp, and instead of this validation check, I have to copy the validation check for temperature here. And here, instead of status, I say temp, and that's it. Now let me create an object from this class. Here I say weather equals weather condition, and I pass invalid arguments, for example foggy and 60. And if I run the code, you can see it says invalid status. And now let me replace foggy with, for example, rainy, and run code again. And again it says invalid temperature. And if I enter a valid temperature between -40 and 40, for example 20 centigrade, and I run the code, you can see it runs without any error. Now let me change the status by saying weather.status equals foggy. And if I run the code, you see that it says status is not valid. But I can say weather.status equals snowy, and now I can print weather.status. And if I run the code, you can see that the status has changed and it is printed here. Hello and welcome back. As I told you, in this chapter we will talk about magic methods in Python that starts and ends with double underscore. In this video we will talk about dunder call dunder method, which can be defined to make an object callable. So let's get started and jump into code to see how we can use this method. Suppose that your team manager has asked you to write a code to model a linear equation. A linear equation with one variable is something like a machine. It has an input x and it returns output y. And the relationship between x and y is determined by this equation, y equals a times x plus b. In this equation, a and b are the parameters of the system. Therefore, a linear model is defined by its parameter. Once the parameters are specified, it can get an input value x and return the output value y. After reading this description of the problem, at first you may decide to write a function that acts as a linear model. So you create a function named linear_model that takes the parameters of the model, including a and b, and its input x. Inside the function, you return the output of the model, which is a times x plus b. At this point, you are happy that the project is done and you submit your code to the team manager. Now other developers can use your function. For example, one of the developers has a linear model with a equals 2 and b equals 3, and he wants to compute the output corresponding to different inputs. In each call, he should pass 2 and 3 as parameters. For example, in part of his code, he wants to compute the output corresponding to 0. So he calls the function like this: out1 equals linear model, and he passed 2, 3, and 0 as the input. Then in some other part of his code, he needs the output for 10. So he writes out2 equals linear model, and again he passes 2, 3, and 10 as input. As you see, because the function requires parameters of the model, each time the developer should pass 2 and 3 to the model to use your function. Let me print the output here and run this code to see the result. As you see in the terminal, the outputs are printed here. The output corresponding to 0 is 3. Why? Because 2 times 0 is 0 and 0 plus 3 is 3. And the output corresponding to 10 is 23, because 2 times 10 is 20 and plus 3 returns 23. This code works well, but the next day your team manager sends you an email to rewrite your code. The other developers find your function a bit cumbersome. They don't want to pass the model parameters each time. Instead, they would like to create a linear system one time and use it for several times. What is the solution for this issue? The solution is creating a class for linear model. So let's go ahead with defining a class for linear model. Here I say class linear model. As I said, a linear model is defined by its parameter. So a and b, the parameters of the model, are attributes for this class. So here the init method takes self and 2 additional parameters, a and b. And inside the init method, I assign these parameters to self object. I say self.a equals a and self.b equals b. Now we have to provide a method for computing y for each input x. Here I define a method called compute that takes self and x as input argument. Inside this method, first I compute the output corresponding to x. So output is equal to self.a times x plus self.b. Now we have to return the output. So I say return output. Well done. The second version of your linear model is ready to use. So you submit your code again to the team manager and the other developers can use this model. The other developer first need to create an object from this class. So he says lm equals linear model, and here he has to pass the parameters of the model, which in our example are 2 and 3. And now to compute the output corresponding to each input variable, he should call the compute method for lm object. Here he can say lm.compute and he needs to pass the input variable, which is 0. And let me store the result in out1. Or out2 equals lm.compute and pass 10. Now let's print out1 and out2 and run the code to see the result. As you can see, the output is the same as the previous code, so it works well. But again, you receive an email from the team manager that the other developers are not happy with compute method. Instead, they would like to call the linear model directly. In other words, instead of this line, they prefer to say out1 equals lm and pass 0 directly to it. Or instead of this line, they prefer to say out2 equals lm and pass 10 to lm. Let's run this code and see the result. As you see, we got an error that says linear model object is not callable. This error is because lm is not a function, it's an object, and it is not callable. You cannot call it like a function. But fortunately, there is a way to make an object callable. You need to define $call$ in your class. Here, inside the class, I define a new method named $call$, and it takes self and input variable x. The body of this function is the same as compute method. So I copy the lines from here and paste it here. And it's done. Now let me run the code to see the result. As you can see, this time I didn't get any error and the code works well. The linear model object is callable now and you can call this directly. Now other developers and the team manager are happy with your code. In this video, you learned how to make an object callable. Most of the time when your object takes an input and returns an output, or it behaves like a function, this method is handy and useful. Now please go to the assignment section and do the assignment for this video. So far you have learned several magic methods in Python, but in this video I'm going to show you a new method that helps you to create an object like list in Python. Lists in Python support indexing. It means you can access each item using its index. Also, lists are iterable, so you can use a for loop to go over items in the list one by one. By default, when you create your own object, it neither supports indexing nor is it iterable. In this video, I will talk about $getItem method. This magic method is used to make an object like a list. So instead of me talking a bunch of words, let's jump into code and get started. As I said in this video, I want to show you how to iterate over an object using a for loop. To better understand the problem, first I give you a very simple example to get a general idea, and then I try to solve a real-life problem that you may encounter in a data analysis project. Sometimes you define a class that one of the attributes is something like a list or any other containers, such as a tuple, dictionary, NumPy array, or pandas data frame. For example, consider a class that represents a shopping list. A shopping list contains a list of items that is a container object. Let me define the shopping list class here. Here I say class shopping list with capital S and capital L. Because this is a very simple example, not a real application, I don't want to make it complex. The init method just takes self as input, and inside this method I define an attribute named items, which is a list of items. In practice, I have to initialize this attribute with an empty list, and then I have to write a method to provide a way for adding items. But here I initialize it with a predefined list of items. Our shopping list contains apple, banana, milk, and carrot. The definition of our shopping list class is complete. Now let's create an object of this class. Here I say shopping list, all lowers, equals shopping list with capital S and capital L. And now I want to ask you some questions, and in the rest of this video I will answer all of these questions. The first question is, can we access the first item in shopping list? In other words, can I say print shopping list and use indexing operator for this object like this by enclosing 0 by a pair of brackets? Let's run this code and see what happens. As you can see in terminal, I got a type error. It says shopping list object does not support indexing. By this error, we learned that when we define our objects, by default they are not support indexing operator. You may access the first item using something like this: print shopping list dot items and then use indexing operator. because you know that items attribute is a list and do support indexing. And let me comment this line and run the code again and see what happens. As you see, this time Apple is printed in the terminal. Although this code works, firstly, it's not as convenient as the first method. And second, what happens if I make the items attribute private? If the items attribute is private, then you cannot access it outside of the class. Well done. Now let's move on to the next question. Can I iterate over this shopping list to print all items? For example, can I say for item in shopping list print item? Again, let me comment the previous statement and run the code to see what happens. As you can see, again, I got an error that says shopping list object is not iterable. So by default, our defined objects are not iterable and we cannot iterate over them using a for loop. Now let's move on to the next question. The third question. Can I use in operator to check if a specific item is in the shopping list? For example, can I say if milk in shopping list, then print you have to buy milk. Now let me comment the previous for loop and run this code to see what happens. As you see, again, unfortunately I got an error. The error is like the previous one. Shopping list object is not iterable. Now you know what the problem is with our object. It doesn't support indexing and it's not iterable. To solve all these problems at once, you just need to define a special method named $getItem$. So inside a class, I define a method named $getItem$, and I pass self to it. Like other magic methods, you don't call this method directly. Instead, when you say, for example, shopping list and put 0 inside a pair of brackets, this method is called behind the scene. So this method gets another parameter named index or IDX, that is the index you put inside a pair of brackets. And inside this method, I return self.items IDX. Well done. Now let's go back to the usage of this class. First, let me uncomment all these lines, and to make them easier to read, let me separate these print statement with a horizontal line. Now let's run our code. As you can see, this time I didn't get any error and the code works successfully. Apple is the first element of our shopping list. These are all items that are printed inside a for loop, and because milk is in the shopping list, it says you have to buy milk. Now let me ask you another question. Suppose that we want to know the number of items in our shopping list. How can I get the length of shopping list? It would be very convenient if I could say print length of shopping list. But if I run the code, you see it shows me an error. It says object of type shopping list has no len method. But don't worry, we can define $len$ method for our class. Here, inside our class, I define a method named $len$ and I pass self as other instance methods. This method should return the number of items in shopping list. So I return the length of self.items. And now if I run the code again, you will see it prints 4 because there are 4 items in shopping list. Well done. Now that you learned the general idea, let me give you a more realistic and practical example. Here I have a folder like this. It contains several images and I want to read all images to process them one by one. Reading files in a folder is a typical task in data analysis projects. You can write codes without any structure to do this task. But if you follow the object-oriented paradigm, your code will be easier to read and maintain. So here, first let me create a new Python file named main2.py. And in this file, I create a class named ImageDataset. In order to create an image dataset, we need the path for the root folder that contains the images. So in the init method of this class, I pass self and root. Inside the init method, first I set self.root to root. To read images, first we need to get the names of images in the folder. To do so, I'm going to use listdir function from OS library. So let me import OS library here in the beginning of our code. Now I can say os.listdir and I need to pass the name of the folder containing the files, which is self.root. This function returns a list containing the name of all images in the root folder. So I store the result as self.filenames. Okay, now let's go ahead and create a sample object of this class. Here, outside of the class, I say ds equals image dataset and I pass the name of the root folder, which is images. Now let me say print ds.filenames to make sure that the code works. And by running the code in the terminal, as you can see, the name of all files are printed here. Now the first question is how many images there are in the dataset. To do this, I would like to say print len ds. But as you know, we haven't yet defined $len method for our class. So inside the class, I say def $len and I pass self and I return the length of self.filenames. And now if I run the code, you can see 22, the number of images, is printed here. Well done. Now I think it would be very useful if I could use indexing for this dataset object. I mean, I would like to say print ds1 to get the first image. But at this time, our image dataset does not support indexing. To support indexing, we have to define $getItem method inside the class. So here I say def $getItem and I pass self and idx. And it returns self.filenames idx. Now let me run the code to see the result. As you can see, the name of the first image is printed here. And now instead of getting the name of the file, I would like to get the image itself. To read images in Python, we can use PIL library. PIL stands for Python Image Library. So at the beginning of our code, I say from PIL, all capital, import image with capital I. And now inside the getItem method, instead of returning the file name, I want to return the image. First, I read the image by saying img equals image.open and I have to pass the path for the image. The path for the image is the root folder plus slash plus the file name. And now I return the image. Now outside of the class, instead of printing ds1, I say img equals ds1. Here img is an image object. And if I say img dot and press tab, you can see lots of methods and attributes for this object. And one of these methods is show, which we can use to show the image. Now let's run the code to see what happens. As you can see by running this code, it opens the image in my computer. Here, if I change 1, for example, to 10, and running the code again, it opens another image for me. Instead of images, you can create a dataset of text files, audios, or any other file formats. In this video, you learned how to create iterable objects that support indexing. Now please go to the assignment section and do the assignment for this video. Hello and welcome back to the last chapter of this course. Dunder or magic methods in Python are the methods having two prefix and suffix underscore in their name. Dunder here means double underscore. A few examples of magic methods are dunder init dunder or dunder str dunder methods that you are already familiar with. Magic methods are not meant to be invoked directly by you. Instead, their invocation happens internally from the class on a certain action. For example, the dunder init dunder method will be called when you create an object, or when you print an object, the dunder str dunder method is called under the hood. In this chapter, you see many of these magic functions. In Python, in many situations, you need to compare two objects. For example, you may compare two numbers to see which one is greater or if they are equal. By default, when you create your own objects, you cannot compare them. However, you can use magic functions to make your object comparable. And in this video, I will show you how to do this in practice. So let's get started and jump into code. To explain the concept of comparison among objects, first of all, I'm going to create a class that represents a student. A student object has two attributes, a name and a dictionary containing the courses and grades. So here, first I define a class named a student, and the init method of this class takes two parameters, self and name. Inside the init method, I initialize the name attribute with name, and because no courses have been taken by a student at the time of creation, I initialize the grades attribute with an empty dictionary. Now let's define a method for adding a course to the student. Here I define add_course method that takes self and two additional parameters, course name and course grade. And it should add the course and grade to self.grades. So here I say self.grades, and inside the brackets I enter course_name, and it equals course_grade. Well, also let me define another method named average that takes self as parameter, and it should calculate and return the average grade for the student. If the length of self.grades is 0, it means that no courses have been added yet, and it returns, for example, -1 to show this situation. Otherwise, it should return the average. To calculate the average, I use the sum method, and I pass the self.grades, that values that contains the grades for the student, to the sum function, and finally I divide it by the length of grades. Okay, after all, let's define $str$ method for printing a student object. So here I define $str$ and I pass self to this method, and as you know, this method returns a formatted string that describes the object. And inside the string, first I enter the name of the class, which is a student, and then I enter the student name, which is self.name, that I have to put it inside a curly bracket, and the number of courses for this student, which is the length of self.grades, and finally the average grade for this student, which is self.average. Well done. The student class is ready to use. And now we can go ahead and create student objects from this class. Here I define S1 and S2 as two students. So I say S1 equals a student, and as you see in the parameter hint window, I'm supposed to enter a name for this student, for example, Alex. And S2 equals a student, and the name is Bob. Now I'm gonna add some courses to each of these students. To add course to S1, I should say s1.add_course, and here I have to pass a name, for example, math, and a grade, for example, 90. And let me add two more courses to S1. For example, s1.add_course, programming, and 98, and s1.add_course, physics, and 92. Similarly, I add two courses to S2. s2.add_course, math, and the grade is 96, and s2.add_course, geography, and the grade is 88. Now let's print these two objects by saying print S1 and print S2, and run the code to see what happens. Okay, as you can see, everything works well. The first student is Alex. He has taken 3 courses, and the average is 93.3. And the second student is Bob with 2 courses, and the average is 92. Now suppose that you need to compare 2 students based on their average grade. For example, here I can say Alex is greater than Bob because his average is greater than that of Bob. Now let's go to the code, and here I say if S1 is greater than S2, then print S1.name, I put it into a curly bracket, has higher grades than S2.name inside curly bracket, and see what happens. As you can see in the terminal, I got an error that says greater operator is not supported between instances of student and student. It makes sense because we didn't specify what we mean by saying S1 is greater than S2. At this point, Python doesn't know anything about the student object. Therefore, to compare two students, we have to define comparison methods for this class. Python has provided us with some methods that we can define to make our objects comparable. To define the greater than operator, we have to define $GT$. GT here stands for greater than. Similarly, to define greater or equal operator, $GE method should be defined. For lower than operator, $LT$ should be defined. And as you can guess, for lower or equal, we should define $LE$ method. Also, there are two more comparison methods for checking equality and non-equality. For checking the equality of two objects, $EQ$ should be defined. And for non-equality, $NE$ should be defined. Now let's go ahead and define $GT$ for the student class. Here, inside the student class, I define $GT$. And like other instance methods, this method has the self as the first argument. Also, because greater than operator is a binary operator, I mean you compare a student with another student, it needs another parameter to refer to the second student. So here I pass another parameter named other that refers to the second student. This is the first thing which is common among all comparison methods. They all have two parameters. The first one is self and the second one is other. Okay, before I go inside this method, I need to talk about comparison operators. Let me open the terminal here and I enter Python to enter the Python shell, and I want to try some comparison operators on numbers. If I say 2 greater than 8, it returns false because 2 is not greater than 8. Or if I say Python is greater than Java, it returns true because Python in alphabetical order is after than Java. The common behavior in comparing objects is that the return value is always a boolean. Now let's go back to our method and complete our $GT$ method. Assume that by saying a student 1 is greater than a student 2, we mean the average grade of a student 1 is greater than average of student 2. So inside the GT method, I need to compare the average of a student 1 and a student 2. Here, the first student is self and the other one is other. So I say if self.average is greater than other.average, then return true. Otherwise, return false. Now let's run our code and see what happens. As you see in the terminal, this time there is no error. And because the average of Alex is greater than the average of Bob, it says Alex has higher grades than Bob. Okay, as you see, our code works. However, if you take a look inside our method, you can see that we can replace all these lines with just one line of code. Here, I comment all these lines, and instead, I just return the result of comparison between the average grade of students. If the condition is true, it returns true. And if the condition is false, it returns false. And now, if I run the code again, you see the code works and the result is the same as previous code. After defining one comparison method, defining other methods is straightforward. You just need to copy and paste the method and apply little changes. Here, let me copy the greater than method and paste it here. And I replace greater than with, for example, lower equal. And inside the method, instead of greater than operator here, I use less than or equal operator. And that's it. Now we can use this method in our code. Here I say if S1 is lower or equal than S2, then prints S1 name has lower grades than S2 name. Otherwise, I print the same message, but I reverse the name. Here I say S2 and here S1. Okay, now let me run the code to see the result. And as you can see here, it says Bob has lower grades than Alex. At this point, you have learned to compare your objects. But before I finish this video, let me give you a bonus tip. When you're defining a comparison method, you have to make sure that both objects are from the same class. If you don't check it, it causes an uncatched exception in execution time. For example, here, let's see what happens if I say if S1 is greater than 90, then print S1.name is a smart student. And if I run the code, you can see an error message in terminal, which says int object has no attribute average. But what is the reason behind this error? As you can see, the error is related to this statement. S1 is greater than 90. When we say S1 is greater than 90, Python goes to the dunder GTDunder method and pass 90 to the method. So other here is 90. And then it tries to call the average method for other, and because int object does not support average method, it causes an error. So we should check the type of parameter other before everything. To ensure that the other object is from a student class, I use isInstance function. Here, before everything, I say if isInstance other and a student, then do this. But if the other is an instance of int or float, then compute the average for self and compare it directly with other and return the result of comparison. Otherwise, if the other is anything else, I raise a value error and the error message is cannot compare a student and other.dunder class dunder name dunder. Now let me add another if statement. For example, if S1 is greater than AAA, then print something. For example, okay. And let's run the code to see the result. As you can see here, we compare a student with a number. And here, because average grade for Alex is greater than 90, it says Alex is the smartest student. But comparing a student with a string is not allowed. So it raises a value error and it says cannot compare a student and str. Well done. In this video, you learned how to define comparison methods to make your object comparable. Now you can go to the assignment section and do the assignment for this video. Hello and welcome back. As you know, there are several operators in Python. For example, consider the plus operator. This operator behaves differently with different types. The plus operator will perform arithmetic addition on two numbers, merge two lists, or concatenate two strings. This feature in Python that allows the same operator to have different meaning according to the context is called operator overloading. In this video, I'm going to show you how to overload operators for your defined classes. So let's get started. As you know, in Python, you can do mathematical operations on numbers. For example, I can say print 1 plus 2. Or I can say print 5 minus 2. Or even I can add two strings. I can say, for example, print united plus state. But as you know, the subtraction is not defined for two strings. So I cannot say print united minus a state. And if I run the code, you can see in the terminal a type error, which says unsupported operand types for minus, str and str. And it means that subtraction is not defined between two str objects. When you define your own classes, Python does not support any mathematical operations. So if you perform any mathematical operations, you will get the same type error. In this video, I'm going to show you how to use magic methods to solve this problem. Because the focus of this video is implementation of mathematical operations on objects, I prefer to define a class that represents a mathematical concept. I'm pretty sure that you are familiar with the definition of point in two-dimensional geometry. A point in two-dimensional coordinate is simply expressed by an ordered pair of numbers. The first number is x coordinate and the second one is y coordinate. If we think of a point as an object, it should have two attributes. One is x coordinate and the other one is y coordinate. So let's define a class that represents a point. First, I remove these lines and here I type class point with capital P and then I define the init method. The init method for this class gets x and y as argument and sets self.x to x and self.y to y. Also, let's define $str method for this class, so we will be able to print point objects. Here I say def $str and I pass self, and inside this method I have to return a formatted string. The string contains the name of the class, which is point, and then self.x inside curly brackets and self.y inside curly brackets. Well done. The definition of the point class is complete. Now let's go ahead and create two sample points. Here I say p1 equals point and I pass 2 and 3 as coordinates. And the second one, p2 equals point and 4 and 5 as its coordinates. And now let's print these 2 points and run the code to see the result. As you see in the terminal, the 2 points are printed as we expect. In mathematics, we can add 2 points. The sum of 2 points is achieved by adding their corresponding coordinates. So given p1 and p2 like this, p1 plus p2 will be this one. Now let's see what happens if I add 2 points here. Here I say print p1 plus p2 and then p1 plus p2. And let me run the code to see what happens. As you see, I got a key error. It says unsupported operand types for plus, point and point. And it means the addition is not defined between 2 point objects. Python actually doesn't know anything about our point class and how the addition is defined between 2 points. To fix this issue, we need to define a special magic method called $add that performs the addition operation for us. So let's define this method for our class. Here, inside the class, I say def $add and as parameter, I pass self and one other point. Because addition is a binary operator, it needs 2 operands. And here, one operand is self and the other one is other. Inside this method, because I know the result of addition of 2 points is a new point, I have to return a new point, which its x coordinate is self.x plus other.x, and its y coordinate is self.y plus other.y. Now let's run our code again to see what happens. As you see this time, the code is working without any error. Now that we have defined the addition operator, we can easily define other operations as well. I just make a copy of $add method here. And for example, I replace add with sub, which stands for subtraction. And inside the method, instead of addition, I say self.x minus other.x and self.y minus other.y. And now I can say print p1 minus p2, comma, p1 minus p2. And by running the code, in terminal, you can see the result of subtraction of 2 points. You can also define multiplication and division for your class. For multiplication, you can define $mul, and for division, you can define $div. Now suppose that I want to add a scalar to a point. For example, here I say print p1 plus 10 and p1 plus 10. In mathematics, when you add a scalar number to a point, it means that this scalar number should be added to x and y separately. Here, let me run the code to see what happens. As you see in terminal, I got an attribute error which says int object has no attribute x. But what is the meaning of this error? When we say p1 plus 10, it calls $add$ method and it passes 10 to this method. Inside this method, the parameter other is equal to 10. And in this line, you are trying to get x attribute for 10, which is invalid because int object does not have x attribute. And as a result, we see attribute error in the terminal. Now that we know the root of this error, let's fix it. Inside this method, before accessing x and y attribute, I have to check the type of the other operand. Here I say if isInstance other and point, then do this. But if the other is an instance of int or float, then I return a new point, which its x attribute is self.x plus other, and its y attribute is self.y plus other. And otherwise, I can raise a type error, and as error message, I enter unsupported operand for plus between a point and other.dunder class dunder dot dunder name dunder. And now I have to format this string. And outside of the class, let me print p1 plus a string, for example hi. And now let's run this code to see what happens. As you can see, everything works except the last line. It says type error unsupported operand for plus between point and str. Now let me show you something surprising. While adding a scalar like this works well, but now let me change the order. Here I say print 10 plus p1 and 10 plus p1. And let me comment this line and run the code again to see what happens. As you can see, again I got an error and it is related to the last line. Unsupported operand types for plus, int, and point. To solve this issue, we should define another method called $radd$. radd means right add, which is for the situation that the point object is in the right hand side of the addition operator. So here inside the class, I define $radd$ method that takes self and other. Now inside this method, I just return self plus other. Here, because I know other plus self is equal to self plus other, instead of other plus self, I return self plus other, because here self is a point and is in the left hand side of the plus. So now let's run the code and see what happens. As you can see now, the addition is fully supported for our point object. We can add 2 points or we can add a scalar to a point. In this video, you learned how to implement mathematical operations for your objects. Now please go to the assignment section and do the assignment for this video. Hi, in this assignment you are supposed to define a text encryption method called Caesar cipher. In general, text encryption means getting a plain text as input and encrypted text in some way and returning the encrypted text as output. In Caesar cipher method, each letter of plain text is replaced by a letter with some fixed number of positions down the alphabet. For example, suppose that the key of the encryption is 3. It means that each letter is replaced by the letter in 3 position in the left. For example, D is replaced by A, because if you start from D and go left 3 steps, you reach A. Also, E will be replaced by B. But what alphabet does letter C replace with? From C, if we go 3 steps left, after 2 steps we reach A. And because there is no alphabet in the left of A, we continue by going to Z. So C will be replaced by Z. And what about A? Go 3 steps back and we reach X. Now that you know how Caesar Cipher works, let me to show you the class that I have created to implement this technique. Here let me create an instance of Caesar Cipher class. I say cipher equals Caesar Cipher, and this class needs a key, which is the encryption key. For example, I pass 3. Now I can call this object like a function. I pass a text and it returns the encryption of the text. For example, I say cipher and I pass hello world. And as you see, it returns the string as a result. Note that any other characters like space are ignored by this object. This cipher object has a method named print mapping, and if I say cipher.printMapping, it prints how letters are encrypted here. You can check if the mapping is correct and whether the encryption works well. Also, the cipher object has a method named decrypt, which converts the encrypted text back to plain text. Here I say print cipher.decrypt, and I copy the encrypted version of hello world to here. And if I run the code, you can see hello world is printed as a result. Now it's your turn to define your Caesar Cipher class with the same behavior. You can pause this video and try to solve the problem, and after that comes back and watch the rest of the video to see my solution. First, I define a class named Caesar Cipher, and in this class I define the init method, which takes a parameter called key and it sets self.key to key. Because in this assignment we need to work with alphabets, I import all lowercase alphabets from a string module. To do so, at the beginning of this code, I say from a string import ASCII lowercase. Before continue, let me print ASCII lowercase to see what it is. As you can see in terminal, it's a string containing all lowercase letters. Okay, now let me delete this line and continue with the definition of the init method. Inside the init method, I set input alphabet to ASCII lowercase. Now, what would be the encrypted alphabet? We need to shift the input alphabet to the left to get the encrypted alphabet. The simplest way to apply a rotational shift to an string or a list is use the slice notation. Here I say encrypted alphabet equals input alphabet from minus key to the end plus input alphabet from beginning to minus key. Now let me print input alphabet and encrypted alphabet to make sure everything is right to this point. Now, outside of the class, let me create an object from this class. For example, cipher equals Caesar Cipher, and I pass 3. Now let me run the code to see what is printed. As you see in the first line, the input alphabet is printed, it's regular alphabet, and the encrypted version is printed in the second line. This tells us that A will be converted to X, and B will be converted to Y, and so on. Okay, now inside the class, we need to define a mapping structure to convert the plain text to encrypted text. Definitely a dictionary would be the best structure to store this mapping. And here I define self.mapping as a dictionary, and as argument I pass a zip of input alphabet and encrypted alphabet. Now here I print cipher.mapping. Now if I run the code, you see the mapping dictionary is printed in the terminal. Well done. Almost the main and difficult part of defining the class is done. Now let's define the print mapping method for this class. To do so, I define a method named printMapping and I pass self as argument. Inside this method, I have to iterate over the mapping dictionary and print each key and value. So I say for key and value in self.mapping.items, print key and an arrow and value. And now instead of printing cipher.mapping, I call cipher.printMapping. As you can see, the mapping is printed here in the terminal. A will be converted to X, B will be converted to Y, and so on. As I told you in the problem definition, this object should behave like a function. For example, I can call this object and I pass hello world. At this time, if I run the code, this line of code causes an error because our object is not callable. So first, inside the class, I define $call method, which takes self and an input text. This method should encrypt each letter in the input text and finally return an encrypted version of the text. So first, I define a new empty string named encrypted text, and then for each letter in text, I add the mapping of letter to encrypted text. And finally, after the for loop, I return encrypted text. Now that we have defined the call method for our object, I can run this code to see what happens. As you see in terminal, there is an error in our code. It's a key error for the dictionary. It's looking for a space in the dictionary and it can't find it. The space between hello and word is the root of this error because this cannot be mapped by the mapping dictionary. To solve this problem inside the call method, to get a value for each letter, instead of bracket notation, I use get method. Get method returns a default value when the key is not in the dictionary. Here I set the default value to an empty string, and it means it ignores any undefined characters. Now here I print the result of this statement. And if I run the code, as you can see, the encrypted version of the hello world is printed here. Okay, now let's go ahead and define decrypt method for this class. The implementation of this method is very similar to the call method, but here the process is reversed. So first, let me make a copy of the call method and apply some changes to it. First, I change the name to decrypt, and it takes self and text, and instead of encrypted text, I say plain text. Also here, and here, instead of self.mapping, we need a reverse mapping. So the best solution is to define reverse mapping in the init method. Here, I make a copy of this line, and I say self.reverse mapping, and I change the order here. And now in decrypt method, instead of mapping, I say reverse mapping. And finally, I return plain text. Now, outside of the class, let me say print cipher.decrypt, and as argument, I say cipher hello world. The inner part encrypt the hello world, and the outer part decrypt it back to the original format. Now let me run the code to see the result. As you see in the terminal, it successfully decrypts the message and hello world is printed here. Hello and welcome back. The aim of this assignment is to make sure you understand you know how to make an iterable object. Suppose that you want to create an object called library. A library has a list of books. At the time of creation, the library is empty and we can add book to the library later. A book has two attributes including title and category. Now let me show you what I have created here and what you need to replicate. Here I have a class named book. To create a book, I say b1 equals book, and I should pass two arguments, title and category. Here I enter Python for title and textbook for category. Now let me create some more books. Here I added two textbooks and two novels. Now it's time to create a library. For this, I define lib equals library. Then I call add method to add the books we have just created. Here I say lib.add and I pass b1. And I do this 4 times to add all the books. Our library objects support indexing. For example, I can say print lib1, which returns the first book, and I can print it because the book object has a str method. Also, I can iterate our library using a for loop. For example, I say for book in lib print book, and it prints all the books for me. Now it's your turn to create book and library for yourself. Please pause the video and try to write your own code, and after that you can play the video to see my solution. First, I create a class for book. The book has two attributes. So in the init method, I have self, title, and category. And inside this method, I set self.title to title and self.category to category. Also, because we need the book to be printable, I define $str method for this class. This method returns a string that describes the object. In the string, I say book and I list the attributes for this book, self.title and self.category. Now let's define a class for library. No argument is needed when we want to create a library, so the init method doesn't have any parameters except self. Inside the init method, I define a list named books, which store the book objects, and I initialize it as an empty list. Now let's define add method. This method takes self and a book. Inside this method, I want to make sure that the input data is book, not anything else. So I say assert is instance book and book with capital B, and if it's not, it prints you can only add book. And now that I'm sure that the input data is book, I append it to self.books. So I say self.books.append book. Okay, to make our library iterable, we need to define $getItem method. This method takes self and index or idx as parameter. And in this method, I return self.books idx. Okay, our class is ready to use and it's time to create objects from this class. First, let me create 4 books. Here I say b1 equals book and I pass Python for the title and textbook for the category. Also b2 equals a man on the moon and it's a novel. And also let me add b3 and b4. And now let me define a library. I say lib equals library and I add the books one by one to this library using add method. And finally here I can print all books in the library using a for loop. Here I say for book in lib print book. And if I run the code, you can see all books are printed in the terminal. Hi, in this assignment you have to create comparable objects. Suppose that we have a class that represents a rectangle. Here I have 2 rectangles, R1 and R2. To compare 2 rectangles, their area will be compared. Here, because the area of R1 is greater than the area of R2, I can say R1 is greater than R2. Now let me show you the output of the code I wrote for this assignment. Here I have defined a class named rectangle. To create a rectangle, I have to pass width and height. For example, I say R1 equals rectangle and I pass 4 and 2. Also, I say R2 equals rectangle, 3 and 4. And now I can say if R1 is greater than R2, print R1 is bigger than R2. Otherwise, print R2 is bigger than R1. And as you see in this example, because R2 is bigger than R1, it says R2 is bigger than R1. Also, I can compare a rectangle with a number. For example, I can say if R1 is greater than 5, print It's a large rectangle. And finally, note that I cannot compare a rectangle with anything else. For example, I cannot compare a rectangle with a string. And if I try to do this, it returns an error with a clear message. As you see, it raises a value error that says greater operator is not supported between rectangle and str object. Now it's your time to define your rectangle class with the same behavior. Please pause this video and try to solve the problem, then come back and watch the rest of the video. Here I define a class for a rectangle, and as I told you, to create a rectangle I need its width and height. So the init method takes self, width and height. And inside this method I say self.width equals width and self.height equals height. Also, I define a method that calculates and returns the area. This method just takes self and returns self.width times self.height. To make our rectangle objects comparable, we need to define comparison operators. Here I define dunder gt_dunder that takes self and another object named other. Inside this method there are three cases. If other is an instance of rectangle, it returns the result of comparison between self.area and other.area. Otherwise, if other is an instance of a number, for example a float or integer, it returns the result of comparison between self.area and the other. And finally, if other is not a rectangle or a number, it raises a value error that says greater operator is not supported between rectangle and other dot dunder class dunder dot dunder name dunder. You can make a copy of this method and change it for other operators. Now let me define two rectangles. R1 is rectangle and I pass 2 and 3, and R2 equals rectangle and I pass 3 and 4. Now I can say if R2 is greater than R1, print R2 is bigger. Also, I can compare a rectangle with a number. For example, I can say if R1 is greater than 1, then print R1 is greater than 1 square meter. Also, let me compare a rectangle with a string and see the result. Here I say if R1 is greater than, for example, hello, then print OK. And now let's run the code to see the results. As you see, the first line shows that R2 is bigger than R1, and the second line tells us R1 is greater than 1 square meter, and finally comparing a rectangle with a string raise a value error that says greater operator is not supported between rectangle and str. The aim of this assignment is to give you a good understanding for implementation of arithmetic operations. In the previous videos, you saw the bank account object. A bank account object has three attributes: a bank account number, holder, and a balance. For this assignment, you have to implement addition and subtraction for the bank account class. Addition means deposit and subtraction means withdraw. For example, suppose that I have a bank account with $10 balance, like this. If I say account equals account minus 2, it means I want to withdraw $2 from this account. Or if I say account equals account plus 10, it means I want to deposit $10. Also, suppose that I have an object named check. Each check has two attributes: the amount of money and the bank account number. I have a bank account like this and a check like this. Now I can say account equals account plus check. In this case, because the account number for check is the same as the bank account number, it means $10 will be deposited to this bank account. But if the bank account numbers are not the same, like this check, it should raise a value error with clear message. Now let me show you these two classes in code. Here I have defined a bank account class, and I can say account1 equals bank account, and I pass the number 123, the holder Alex, and the balance $50. Now let me print this bank account. As you see, everything is okay. Now I want to deposit $20 to this account. So I say account1 equals account1 plus 20. And again, let me print the bank account. And as you can see, the balance now is $70. Also, I can say account1 equals account1 minus 20. And if I print the bank account, you can see the balance now is $50 again. Note that I can't withdraw money more than the balance. Here I have $50 in my account, and if I say account1 equals account1 minus $60, as you see, it returns a value error that says the amount exceeds the balance limit. And if I print a bank account again, you see it still have $50. Now let me create two checks. ch1 equals check, and the account number is 123, and the amount is $100. And ch2 equals check 999 as account number and $200 for the amount. Now I say account1 equals account1 plus ch1. It means I want to deposit this check into this bank account. And because the account numbers are the same, there is no problem with this transaction. And if I print the bank account, you see the balance is $150. But now let me deposit the second check, ch2, to this account. So I say account1 equals account1 plus ch2. And as you can see, it raised a value error that says mismatched account number and check number. Now please pause the video and try to replicate these two classes, and then come back and watch the rest of the video to see my solution. First, let me create the bank account class. The init method takes self, number, holder, and balance. And I set self.number to number, self.holder to holder, and self.balance to balance. Now I define $str method to be able to print the bank account object. This method returns a formatted string, and in this string I enter bank account, and I list the attributes for the bank account object: self.number, self.holder, and self.balance. Okay, now this is the time to write the most important part of this code: overloading addition and subtraction operators for this class. To overload addition, I define $add method, which takes self and an object called other. As I told you, we can add a number or a check to a bank account. So here I say if is instance other and int or float, then return a new bank account, which the number is self.number, the holder is self.holder, but the balance is self.balance plus other. Otherwise, if the other is an instance of check, it should return something like the previous one. So I copy the previous statement, but here instead of saying plus other, because I know other is a check, I say plus other.amount. And in other cases, it raises a value error, and the error message is addition is not defined between bank account and other.dunder class dunder name dunder. Also, as you learned in the tutorials, to define right addition, I should define dunder or add dunder, and I pass self and other. And inside this method, I just return self plus other. Now let me to copy these two methods for implementing subtraction. Here I change add to sub, and because I want to prevent withdrawing money more than balance, say if self.balance is less than other, raise value error, and the message is amount exceeds the balance. Else do the transaction, but I change plus to minus. And I don't need the second part because I don't want to withdraw a check from the bank account. And here, instead of radd, I say rsop, and I return self minus other. Now let me define a class for check. The init method takes account number and amount, and it sets self.amount to amount and self.number to number. Now let's go ahead and define some objects from these two classes. Here I say account1 equals bank account, and I pass 1, 2, 3, Alex, and $50. Now let me print this bank account. And next I deposit $20 to this account by saying account1 equals account1 plus $20. And again, I print the bank account to see how much is the balance. Now I want to withdraw $20, so I say account1 equals account1 minus $20, and I print account1. Also, let me withdraw more than the balance, for example, $100. So I say account1 equals account1 minus $100, and I print the bank account again. Now let me create two checks. ch1 equals check, and the account number is 123, and the amount is $100. And ch2 equals check 999 as account number and $200 for amount. In the first step, I deposit check 1 to the bank account by saying account1 equals account1 plus ch1. And I print account1 again. And in the next step, I want to deposit the second check. So I say account1 equals account1 plus ch2. And I print a bank account again. And finally, after writing more than 50 lines of code, let me run the code to see the results. As you can see, at first we created a bank account with $50 as balance, so it is printed here. And after that, I deposit $20, so the balance would be $70. And in the next step, I withdraw $20 again, and the balance is $50. Next, I try to withdraw $100, which is less than $50. So I got the value error, which says amount exceeds the balance limit, and the execution is terminated. So let me comment these two lines and run the code again. This time the last two lines shows us that both checks have been deposited to the bank account. And this is not correct because the second check has different bank account number. And this is because we forgot to check the account number for check and account number for bank account. So let's go back to addition operation. Here, if the order is a check, I have to check the similarity between the account number for check and bank account. So here I say if other.number equals self.number, then do this. Otherwise, it raises a value error that says mismatched account number and check number. And now let me run the code again to see the result. Here in the output, as you can see, we cannot deposit the second check to the bank account, and it says mismatched account number and check number.